Yes, friends, good evening. This is Sura Singh. In the Sura Singh speaking from Bharat, India. Concrete specifications. As usual, this is third time I'm giving you this from page. I will not repeat previous pages, so this is going to be page 215. I say 215, and I'll reach there. I'm sorry, 115. It's 115, and it is there. So, mechanical spices. Mechanical spices. Mechanical spices stock vessels shall comply with EN 1921-1 or BS 8666 and shall be where indicated on drawings. Details of mechanical splice shall be submitted to engineer for approval. Bundling and splicing of bundle bars. Bundling and splicing of bundle bars shall be in accordance with EN 199211 or BS 8666. Splicing except where indicated on drawings or approved shop drawing will not be permitted. Without approval of engineer examination, contract shall notify the engineer at least 24 hours before commencing fixing of reinforcement or to facilitate the inspection of forms. Contractor shall ensure that areas receiving reinforcement are cleaned before fixing. Electrolytic action. Reinforcement shall not be fixed or placed in contact with non-ferrous metals. Cover concrete cover. Reinforcement shall be maintained with aid of approved spacer pieces. Cover shall not be less than given in section 5 part 6. Spacers, chairs, and other support shall be provided as necessary to maintain reinforcement in its correct position in a member where nominal coverage dimension to links, spacers between links and formwork shall be same dimensions as nominal cover. Spacer bar, very important point. Spacer bar shall be of same diameter as longitudinal bars, but shall not be less than 25 mm in diameter, and shall be fixed between two layers at 1.5 meter centers, except where bundle bars are detailed. Spacer bars are provided within layers of reinforcement, where layers is given other beams or in columns where so spacer bars are required there. You must understand that just like spacer covers are there, spacer bars also there, where multi-layer reinforcement is given. Spacers, chairs, and other supports shall be made of concrete plasters or the materials to approval of engineer where supports are made of concrete. They shall have at least same cube strength as concrete in-house member. Reinforcement, placing of all reinforcement still partially checked by engineer, and in no cases in no cases concrete to be placed around reinforcement steel that has not been approved by engineer. Insertion of bars into or removal of bars from concrete already placed shall not be permitted. Reinforcement still temporarily left. Reinforcement is still temporarily left projecting from concrete at joints shall not be bent without prior approval of engineer. Forms and linings. Damage to forms and linings shall be avoided. Tanking reinforcement shall not be fixed until completion of placing tanking membrane protection, adjustment and cleaning. Check position of reinforcement before and during placing concrete. Pay particular attention to position of top reinforcement in cantilever sections. Ensure that reinforcement is clean and free from corrosive putting, loose rust, loose metal, scale, oil, and other substances which may adversely affect reinforcement, concrete, or bond into protection. Protect projecting reinforcement from weather, red rust, staining of exposed concrete surfaces may occur at time of concreting or reinforcement steel shall have been thoroughly cleaned and freed from all mud, oil, or whatever other coatings that might destroy or reduce bond. Clean all set or partial set concrete which may have been deposited thereon during placing of a previous lift of concrete. All uncoated rust bars shall be again sandblasted and pressure washed. Immediately before concreting, placing and reinforcing steel shall be washed thoroughly with high pressure potable water jets. Remove whatever deposited salts. Repeat. Immediately before concrete placing, reinforcing steel shall be washed thoroughly with high pressure potable water jets. Remove whatever deposited salts. Protective coatings to reinforcement. All foregoing classes of this apply as part apply for the epoxy coated reinforcing bars, reinforcing shell, reinforcing steel which are to be coated shall be free of silver, slivers, scraps, excessive pitting, rust, grease, oil, and other surface defects detrimental to proper coating. Surface shall be prepared in accordance with ISO 14654. Coating shall be applied to clean surface as soon as possible after cleaning and before whatever visible oxidation to surface occurs. Reinforcing steel shall not have surface defects that would be detrimental to coating. Coating material shall be epoxy resin powders as specified in ISO 14654 and ISO 14656 for coating of reinforcing bars and as follows. Epoxy resin powders which do not meet above requirements must be tested by an approved independent testing laboratory and accepted by engineer before use. And this is epoxy resin powders which do not meet requirements. This required must be tested by an approved independent testing laboratory and accepted by engineer before use. Only fusion bonded epoxy coating reinforcing steel will be accepted. No other means of epoxy coating shall be approved. Patching method shall be furnished by epoxy coating manufacturer compatible with coating inert in concrete, suitable for repairs to coated reinforcing bars to be made by coating applicator and contractor at project site. Fabrication shall be performed before coating except as hereafter specified for bent bars and straight bars less than 7.6 meter long. Bent reinforcing steel bars shall be coated after bending unless fabricator can show that satisfactory results can be obtained by coating before bending. Whatever visible cracks in coating on outside of band damage to coating resulting in debonding of coating after bending shall be rechecked. I repeat, whatever visible cracks in coating on outside of band or damage to coating resulting in debonding of coating after bending shall be rejected. Bar less than 7.6 meter long may be sheared or sawn to length after coating provided and damage to coating does not extend more than 12 meter back. Cut and is patched before whatever visible oxidation appears. Flame cutting shall not be permitted. Epoxy coating shall be checked visually after cure for continuity of coating and shall be free from holes, contamination, cracks and damaged areas. There shall not be more than 2 holidays when hole not visibly discernible in whatever 300 mm of epoxy coated bars. A holiday detector shall be used in accordance with the manufacturer's instruction to check epoxy coating for holidays. A 67.5 volt detector shall, such as Tinker and Ricer model M1 or its approved equivalent shall be used. Patching of holidays is not required if there are less than 3 holidays per 300 mm length. Bars having 3 or more holidays per 300 mm shall be cleaned and recoated or replaced as directed by engineer. Epoxy coating film shall be cured and or post-cured to a fully cured condition. A representative proportion of each production lot shall be checked by epoxy coating applicator using method most effective for measuring cure to ensure that entire production of lot of epoxy coating is supplied in full cured condition. Contractor shall repair all coating damaged by fixtures used to handle or support bars in coating process as follows. Patching shall be done as soon as possible and before visible oxidation occurs. Excessive patching for other causes shall not be permitted. Satisfactory correction shall consist of proper adjustments of process and rerunning bars through plant. Engineer reserves right for access to epoxy coating applicators plan to witness epoxy coating processes for project work and to obtain specimen from test bars for whatever testing desired. All chairs and wires and other devices used in connecting, supporting, securing or fastening epoxy coated reinforcement steel shall be made of or coated with dielectric material. Before reinforcing is lowered into place and before placement of concrete coated bars shall be inspected by engineer for damage to epoxy coating, shear ends of bars and other areas required limited repair due to scars and more minor defects shall be repaired using specified patching or repair method. Handling of epoxy coated reinforcement steel bars shall be handled and stored in a manner to prevent damage to bars or where used epoxy coating bars or where use epoxy coating damage in handling or other operations shall be satisfactorily repaired at no additional cost to employer. Where epoxy coated bars are used in handling system shall have plastic mandrels and padded padded contact areas where possible where epoxy-coated bars are used. All bundling bands shall be padded. All bundles shall be lifted with a strong back, multiple supports or a platform bridge so as to prevent bar-to-bar abrasion from sags and bundle bars. Bars or bundles shall not be dropped or dragged during vibration. During vibration, care shall be taken to ensure that the epoxy-coated reinforcement is not damaged by poppers. Testing of epoxy-coated reinforcement. Addition and flexibility of epoxy coating shall be evaluated on the test bars coated with each production lot. At least 1% of length of 6 meters, whichever is less of each size of bar to be coated, shall be furnished as test bars. Test bars may be one length of multiple length as required to have one test bars of each size with each production lot. The production epoxy coated test bar shall be evaluated by bending 120 degrees of the rebound around the mandrel of a diameter corresponding to the size of bars indicated in table this one. So we have just talked of this mandrel 10 mm diameter. This is epoxy coated bar mandrel 10 mm, 79 mm, 12 dia, 95, 13 dia, 103, 14 dia, 111, 16 dia, 127, 18 dia, 143, 20 dia, 159, 22, 175, 24, 191, 25, 198 mm, 26, 1206 mm, 28, 222 mm, 32, 38 mm, 32 dia, 254 mm, 34 dia, 270 mm, 36 dia, 286 mm. Bench shall be made at uniform rate and may take up to 1 minute to complete. Bend shall be conducted at room temperature between 20 to 30 degrees Celsius after specimen has been exposed to room temperature for a sufficient time to ensure that it has raised thermal equilibrium. No cracking of epoxy coating shall be visible in by naked eye on the outside rails of the surface and the part of epoxy. We have talked of this joints. We have talked yesterday the joints. I'm just trying to overlap the courses of these joints. I will not overlap. I leave it as it is. You can read yourself. It's not very important. We have talked of in this various schools of, and we have talked some methods, and we have talked in this all kinds of joints. Quality definition, etc. We have talked about construction joint. We have talked about contraction joint. We have talked about extension joint. We have talked about isolation joint. We have talked joint failures. We have talked about the details, and we have talked about construction joints. We have taken in-depth study of that with yesterday slabs. We have wherever it is coming, we have to do all that. Construction joints and water handling structure. We have talked about that one as well. So we have talked about water stops. We have water stop. We have talked about that one. So we will not repeat that movement joints. So we have talked about, and then we have talked about joint filler, etc., and joint sealants. We have talked about all. So hardness of the properties we have talked, sealant properties we have talked, and because they are the joint sealant is to be in contact with protective coating. Contact the shell, satisfying that sealant and protective coating are compatible. Sealant very important. That's why I'm going to repeat properties of this. Movement accommodation factor is 25%. Sure, a hardness is 20 to 25. Solids content 100%. Surface temperature range 0 to 90 degrees Celsius. Chemical resistance of sewage, subcommon mineral acids and alkalis. Subcommon means salts contained in earth. So this is chemical resistance, sewage, subcommon mineral acids and alkalis with depth ratio is to 1. This is all about joints. So we can move further. Slip bearings we have talked yesterday. We have talked the slip bearings, and we have talked various water stops we have talked. So I'm not going to repeat that. You can do this. Then we have to talk about minimum test performance that the PVC water stop shall be as per tensile greater than 12 MPa. Elongation of that is 300%. Hardness of 80 to 90. Method shall be tested in the cogs BS257 or BS2782 or CRD C572 or the STD and the 2240. And butyl rubber water stops, we have talked about that one as well. Water swelling gaskets, we have talked of. And freshwater seawater chemicals at the end of part of this. So we'll go on to next inspection, testing of hardness. Hardened concrete. Now this is very important part for supervisor, for supervisor engineer and consultant as well as structural engineer. It's very important part, very important I can say from quality viewpoints, hardened concrete inspection and testing of hardened concrete. Let's go start this inspection and testing of hardened concrete. In this scope, references submitters, quality assurance, non-compliance of general field work requirements, concrete course, general drilling course, testing of strength, assessment of strength, reinforcement cover measurement, ultrasonic pulse measurements, general selection of testing locations and execution of test, estimated in situ cube, strength radiography of concrete surface hardness, general method of test equipment, reporting chemical content, sampling laboratory testing. Now we're going to the inspection testing of hardened concrete general. This part of specification covers inspection, sampling and testing of hardened concrete. Related sections and parts as follows. Property requirements. Then we have a reference ASCI 214R, 4R. Guide for obtaining coarse and interpreting compressive strength results. ACI 318 ERTA building code requirement for structural concrete ACI 31808 and commentary ASTM C42 standard test method for obtaining and testing drilled cores and sawed beams of concrete than ASTM C8223, that is standard practice of examining and sampling of hardened concrete construction. BS 18811 for testing concrete method of analysis of hardened concrete, then BS 18812 for testing concrete recommendations on use of electromagnetic co-meters, then BSEN 12350 testing fresh concrete, then BSEN 125041 testing concrete structures core specimens, taking, examining and testing in compression. BSEN 125042 non-destructive testing, determination of rebound number. BSEN 12504-32 testing concrete structures, determination of pull-out force. BSEN 12504 for determination of ultrasonic pulse velocity. BSEN 1379 assessment of in situ compressive strength in structures and precast concrete component. GSO ISO 19206 testing of concrete part 6 sampling, preparation and testing of concrete core. Submittals contract shall submit to engineers quality assurance procedures for particular parts of testing work that shall be carried out. Contract shall submit to engineer's approval curriculum vitae of supervisors proposed for work. Then contract shall through testing agency prepare a factual report that identifies test methods used and test results. A report shall also identify unusual results of pertinent information relating to testing. A report shall be presented in hard and electronic copy. For each of test results, contract shall identify precision or repeatability of particular sampling and testing method. This shall be as given from experience of particular test by laboratory or expected from information in particular test standard in place. Tests will be valid only if tests have been conducted using properly calibrated equipment in accordance with recognized standard procedures and acceptable correlation between test results and I missed it, sorry. This is in place. Tests will be valid only if tests have been conducted using properly calibrated equipment in accordance with the recognized standard procedures and acceptable correlation between test results when concrete compressive strength has been established and is submitted. Non-destructive tests shall not be used as sole basis for accepting or rejecting concrete, but may be used to evaluate concrete when standard code strengths fail to meet specified strength criteria of quality assurance or requirement. All field and laboratory testing of concrete shall be carried out by an independent laboratory approved by engineers. Evaluation of concrete and structure is needed when an existing structure will be modified or redesigned to assess structural adequacy when doubt arises about compressive strength in structure due to defective workmanship, deterioration of concrete due to fire or other causes. When an assessment of in situ concrete is needed during construction to assess structural adequacy in case of non-conformity of compressive strength obtained from standard test specimen. Assessment of conformity of in situ concrete compressive strength and specified in a specification or product standard. Non-compliance of work in 28 days work with test tubes as defined in clause 6 of the section fails to meet minimum criteria. Engineers shall direct contractors to carry out the place methods to estimate concrete strength by non-destructive testing in situ, drilling of concrete cores or load testing. Parts of elements of structure made from defective batches of concrete is represented by work. Test cubes shall be identified by engineer, and based on this information, engineer shall instruct contractor on required number and position of concrete cores. Engineer shall review a concrete test results in conjunction with BSEN 13791 or ACI 318, which is applicable to structural design. Based on this assessment, the engineer shall decide the acceptability of concrete in a structural element and may either accept or accept concrete, instruct that certain remedial work are carried out, instruct that element is replaced. General field work requirements. General field work requirements. Let us see that. Contractor shall make all arrangements to provide safe, stable access to testing locations When gaining access to testing locations and whilst testing concrete shall take care not to damage structure or leave it in untidy or unclean state. Contractors shall take precautions to ensure that cooling water from concrete coring or other operations is discharged such as not to cause a mess or damage interior exterior part of structure. Contractor shall be responsible for arranging water supply required for testing. Contractor shall arrange for suitable power supplies where the testing is being carried out on an occupied structure. A power supply from building services may not be available, and contractor shall make arrangements for power supply extension leads of adequate length. Contract shall be appointed, contract shall appoint qualified field supervisor to coordinate and manage field work. Supervisor shall have no less than 5 years experience of such work, maybe more. Before starting work, engineer with contract supervisor make positions where field testing is to be carried out. A unique referencing system to identify each sample of testing location be adopted, and this shall either be referenced on sketch plans or drawings by detailed description used throughout report or to identify test locations. If testing is being carried out on an occupied structure, contract shall coordinate with owner, operator of structure to arrange detailed program for works and give access to various parts of structure. As soon as laboratory tests are available, these shall be submitted by hand or faxed to engineer in draft form. Testing laboratory or technical bureau assigned by testing agency assigned by contractor shall provide a technical report providing visual inspection and analysis of test conducted. All core holes, the sample holes and exploratory investigations area shall be reinstated with a proprietary non-shrink cementitious repair mortar. Preparation of holes or areas before reinstatement shall be carried out per recommendation of repair mortar supplier. Before filling core holes, the sample holes or exploratory investigations areas, contractor shall allow engineer time to inspect these areas and obtain written confirmation from engineer before filling concrete cores. General drilling and testing of cores shall be carried out in accordance with BSEN 13791 and BSEN 125041 or GSO ISO 1920-6 or ASTM C42 or ASCI 214.4, whichever is applicable to structural design. All supplementary information listed by relevant standards shall be included in test report with photographs of course. An assessment of in situ compressible strength for a particular test region shall be based on at least 3 cores. Consideration shall be given to whatever structural implications resulting from thickning. Course diameter of concrete core shall be at 100 mm for strength evaluation unless clear spacing or reinforcement is less than 100 mm and approved by engineer. Preferred minimum core diameter is 3 times the nominal maximum size of core aggregate, but shall be at least 2 times nominal maximum size of course aggregate. The engineer will advise required number and location of course. If results of initial coring are inconclusive, engineer may instruct their further course for be taken at certain locations. Unless otherwise directed by engineer, contractor shall ensure that coring doesn't cut through whatever reinforcement is steel. The required diameter and depth of concrete core shall be as given in table 13.1. Minimum depth of sampling of core for testing purposes ASTM 823. One column is types of construction, thickness of section, meter, minimum depth to be sampled, meter, slabs, pavements, walls, linings, foundations, structural elements accessible from one side only, 0.3 or less, that's thickness of section, or is 0.3 or more or greater. So when it's 0.3 or less, entire depth we have to do. When it's 0.3 or greater, 0.3 we have to take core off. Suspended slabs, walls, conduits, foundations, structural elements exposed to atmosphere, 2 or more sides, 2 or more such concrete products. So if it's 0.15 or less, entire depth is 0.15 to 0.6, 1/2 thickness or 0.1 whichever is greater. Then massive section 0.6 or greater, 0.6. Requirements of table 13.2.1 may not provide quantities or dimensions of samples that are required for all tests. In that case, necessary additional quantity of concrete in pieces of appropriate minimum size should be taken at each sampling location. When suspended slabs are cored, it is desirable to leave lower 25 mm uncored so as not to lose core vibes falling from barrel and to make it easier to patch core hole. Drilling course. Before beginning Coring operations, contractors shall use proprietary cover meter to identify position of steel, requiring require reinforcing bars at testing location. The engineer may instruct that core is taken through concrete without hitting reinforcement, or engineer may instruct that core is taken in a position it is expected where it is expected reinforcement be cut in order to provide a sample of reinforcement to check its condition. Locations of drilling points shall be chosen so that the core contains no steel parallel to its length. Before capping, core shall have a length of at least 95% of its diameter. Once prepared for test, core shall have a length of at least equal to diameter and not more than 1.2 times its diameter. Cores of both 100 mm and 150 mm nominal diameters may be tested provided that aggregate size does not exceed 20 mm and 40 mm respectively. In case of 100 mm, we have 20 mm aggregate. In case of 150 mm nominal diameter, and aggregate size is 40 mm. Where possible, 150 mm core should be taken to reduce variability due to drilling and increase reliability of testing unless reinforcement is congested, and use of 100 mm core shall reduce possibility that core shall contain steel, or it is necessary to restrict assembling to a length of less than 150 mm. Where size of section precludes use of 100 mm or 150 mm cores, a smaller cores may be used with permission of engineer. Yeah. Now, during drilling operations, a log of observations that may affect the interpretation of core samples shall be prepared. If instructed by engineer, immediately after core has been cut and removed, structure a carbonation test will be carried out by using 1 or 2% solution of phenol phthalate poured over cut surface. A photograph shall be taken of cut core with phenol phthalate solution applied to provide a record of test. If during drilling of core collapses due to weak honeycomb or defective concrete, contractor shall stop drilling operation and carry out testing at an adjacent location as advised by engineer. If when testing at second location, core again breaks due to honeycombed or defective concrete, freshly cut core shall be retained for reference and a note made of condition. Testing for strength. Compressive strength of field concrete core shall be assessed in accordance with BS-EN 13791. Details of concrete core in accordance with BS-EN 13791 shall be recorded, and 2 photographs on each side of core taken. Where there is reinforcement in core, size and type of bar shall be noted along with its cover to concrete surface. Condition of reinforcing bar shall be noted with a detailed description of whatever corrosion of reinforcement. Before carrying out compressive strength testing of cores, contractor shall inform engineer to allow him to witness testing if required. Crushed core sample shall be retained by laboratory and only disposed of after written approval by engineer. Assessment of strength. Assessment of strength and estimated institute strength of concrete shall be calculated from core result using BS-EN 13791, SAI 214.4 or SAI 318, whichever is applicable by structural design. Reinforcement cover measurement. Measurement of cover to reinforcing steel and other metallic items in concrete shall be carried out in accordance with BS 1881 Part 204 using an electromagnetic device that estimates position, depth and size of reinforcement. Locations for checking cover and spacing within the measurements shall be advised by engineer based on objective of investigation. Contractor shall carry out calibrations of electromagnetic device for a particular bar size to allow bar diameter to be measured, while testing orientation of steel bar shall be checked. Electromagnetic device shall incorporate scale or digital display range and shall be calibrated in accordance with BS 181 Part 204. When calibrated in this manner, indicated cover to reinforcement shall be accurate within plus minus 5% or plus minus 2 mm, whichever is greater over working range given by manufacturer. Cover meter shall be used in accordance with manufacturer's instruction and checks or zero carried out as specified. Search head shall be traversed systematically across concrete and where reinforcement is located, rotated until maximum disturbance with electromagnetic field is indicated by meter. Cover 2 reinforcement shall be noted along with axis of reinforcement. Cover shall also be recorded on concrete surface with chalk or a suitable non-permanent marking pen. Care shall be taken to avoid interference from other metallic sources or magnetic material. Cover meter checks shall be carried out by an operator with 5 years experience minimum. Test report on cover shall include following information: date, time and place of test, description of structure or component under investigation, location of test areas, make and type of cover meter used, date of last laboratory calibration or of cover meter. Details of site calibration of cover meter, indicated values of cover, estimated accuracy of quantitative measurements, configuration of steel reinforcement. Ultrasonic pulse meters. Ultrasonic velocity test equipment shall be capable of measuring transit time of pulse vibration through concrete, length of pulse, part between transducer equipment shall be measured and pulse velocity calculated. Ultrasonic pulse velocity testing shall be carried out in accordance with provisions of BS EN 12504-4. Velocity shall be measured at a number of locations around structure and velocity contour of structure established. A minimum of 40 velocity shall be measured for each structural element. Selection of test locations. Wherever possible, direct transmission arrangement shall be used. Transducer shall be mounted on a specially formed molded surface. Minimum path length shall be 100 mm for concrete in which nominal maximum size of aggregate is 20 mm or less, and 150 mm for concrete in which nominal meaning maximum size of aggregate is between 20 mm and 40 mm, but path length shall not be longer than required to detect small region of bad concrete. Where concrete contains steel, pulse velocity shall be adjusted in accordance with requirement of BSE and 12504-4. Locations that contain reinforcement directly along or close to pulse paths shall be avoided. Where repositioning is not possible, semi-direct transmission measurement where transducers are placed on adjacent faces of concrete may be used. Execution of tests. Position chosen for test location shall be clearly and accurately marked on surface of concrete. Surface of concrete shall be cleaned and free from grit and dust. Path length shall be determined in accuracy of 1 plus minus 1% and a suitable cup length, such as grace applied to each of test points. Pulse transit time shall be measured by a skilled operator with a minimum of 5 years experience in use of equipment. Pulse velocity measurement equipment shall be in accordance with the requirement of BSE and 12504-4. Test results shall be examined and whatever unusual readings repeated carefully for verification or amendments, then estimated in situ cube strength. A correlation shall be established between cube crushing strength of a particular mix used in structure and pulse velocity. A correlation shall be established between cube crushing strength of particular mix used in structure and pulse velocity. Where it's not possible to obtain cubes with same mix design as original structure, a combination of coring and ultrasonic pulse velocity testing may be carried out at direction of engineer. Where cores are used to provide correlation information required by interpretation of ultrasonic pulse velocity test, Radiography of concrete, gamma rays and high energy X-rays, which illustrate by radiographs concrete defects that shall be carried out in accordance with requirements of BS 1881-205 or equivalent. Surface hardness. General testing of concrete surfaces for hardness using a rebound hammer shall be carried out in accordance with BSEN 12504-2. Rebound hammer shall only be used for estimation of concrete strength where a specific correlation is carried out of concrete from structure being tested. This shall be from work test cubes or cores taken from structure. Correlation between concrete strength and rebound number shall be carried out in accordance with BSE 125042. Precision of correlation curve between mean rebound number and strength shall be stated, and this will be used when reporting whatever strength interpretations from surface hardness readings. Use of general manufacturers correlation or calibration curve for strength shall not be used. It should be noted that the rebound hammer number only provides information on surface layer of approximately 30 mm in depth of concrete, and that should be quoted in test report. Should be quoted. Rebound hammer may be used to establish uniformity of finished product or similar elements in structure at constant age, temperature, maturity, and moisture condition. Method of test. A minimum of 12 readings shall be taken to establish a single surface hardness at a particular location. Readings shall be on a regular and grid between 20 to 50 mm spacing over an area not exceeding 300 mm by 300 mm. Mean of each set of readings shall be calculated including abnormally high and abnormally low results, unless there is a good reason to doubt validity of a particular reading. Coefficient of variation and standard deviation of reading shall be reported. Equipment. Rebound hammer shall be a proprietary type that has been used successfully and serviced by a minimum of 5 years. Hammer shall comprise of a mass propelled by a spring that strikes a plunger in contact with surface. Manufacturer's literature shall identify impact energy and contact area of plunger for hammer. Reporting. Test report shall affirm that hardness was determined in accordance with BSEN 12504-2 and shall provide following information: date, time and place of test, description of structure and location of test, details of concrete type of cement content, type of aggregate, type of curing age of concrete, type of compaction of concrete, forming of surface, moisture condition of surface, carbonation state of surface, suspended movement of concrete under test, direction of test, other factors that are considered significant in influencing hardness readings, details of rebound hammer correlation with the strength including mean, range, standard deviation and coefficients, and variation of each reading shall also be included. Chemical content sampling. Engineer shall instruct depth increments over which dust samples area are to be taken. Types of chemical testing to be carried out and quantity of samples required. Depth of sample shall not be less than concrete cover to reinforcement and at least 50 mm from surface of concrete. Presence of reinforcement chemical content shall be tested at least 2 levels before and after depth of reinforcement from surface of concrete. To provide uniform samples of cement matrix and aggregate, 3 separate holes shall be drilled at one location. Diameter of holes shall be between 12 and 20 mm. Care shall be taken to discard material from whatever render or finish unless this is specifically required under investigation. Care shall be taken to ensure that dust increments are accurately measured by marking drill bit. Dust samples increments shall be carefully transferred to plastic bags and sealed to avoid contamination. Each sealed bag shall be uniquely identified by sample identification and depth increment. Laboratory testing. Residual split samples of dust from field investigation shall be retained until an engineer has reviewed chloride test results. Engineer may instruct that repeat tests are carried out on certain samples. Chloride testing of concrete dust samples shall be by an acid-soluble method in accordance with BS 1881 Part 124. Results shall be reported to 2 decimal places. Sulfate testing of concrete dust samples shall be in accordance with BS 1881 Part 124 using an acid-soluble method. Now it is protective treatment for concrete. It's very important item. Protective treatment. Protective treatment for concrete, which is for all concretes below ground or above ground. Very important item. Very important item, you may say. Not only important, extraordinarily important. This is, if concrete is not protected, there's no use. Protective treatment for concrete. Protective treatment for concrete. Let us say like this. Protective treatment for concrete. Scope references, submittals, quality assurance, pre-installation coordination, delivery, storage and handling, protection, general requirements for all treatment, final inspection, epoxy coating, general, surface preparation, material application, materials application, epoxy coating, general, surface preparation, material application, waterproof membrane, general materials, waterproof membrane application, penetrative primer, general materials, surface preparation, application, protective coating, general, surface preparation, material application, plastic sheet liner for concrete surfaces, structures. General shop drawings and submittals, liner material requirements, plastic sheet liner strip properties, basic sheet dimensions, liner details, installation, testing requirements, special requirements, joint and lining for in situ concrete structures, testing and repairing damages surfaces. बस ऐसे ही है, अभी टेस्ट कर रहे हैं. ठीक तभी होंगे जब ऐसे ही होगा ना. Liner details, installation, testing requirements, special requirements, joints in lining for in situ concrete structures, testing and repairing damaged surfaces, protective treatments for concrete. Protective treatment for concrete. जरा इसको सैनिटाइज कर देना. This part covers materials application requirements for coating for concrete surfaces. This part covers materials and application requirements for coatings for concrete surfaces, including epoxy coating, waterproof membrane, penetrative primers, protective coatings and treatments for specialist applications where there is a harsh environment. Related sections and parts are as follows. Part 1, general references. Following standards are references or reference to in this part. ASTM D412 test methods for vulcanized rubbers and thermoplastic elastomer tension. ASTM D543 test methods for resistance of plastics to chemical reagents. ASTM D570 test methods for water absorption of plastics. ASTM D638 test methods for tensile properties of plastics matrix. ASTM D746 test methods for brittleness, temperature of plastics and elastomers by impact. ASTM D882 test methods for tensile properties of thin plastic sheeting. ASTM D1000 test methods for pressure sensitive adhesive coated tapes used for electrical and electronic applications. ASTM D1004 test methods for initial tearing, resistance of plastic film and sheeting. ASTM D4541 test methods for pull-off strength of coatings using portable adhesion testers. ASTM E96 test methods for water vapor transmission of materials. ASTM E154 test methods for water vapor retarders used in contact with earth, under concrete slabs, on walls, or as ground cover. BS181 testing concrete. This BS1881, BS EN12350 testing fresh concrete. Syria Technical Note 130 protection of reinforced concrete by surface treatments. ISO 9000 quality management and quality assurance standards. ISO 9001 quality system model for quality assurance in design development production solutions. तो सैनिटाइज करते ना कोई आया था अभी, कौन था पता नहीं, मुझे था आया था. Submittals. Contractor shall submit manufacturer specification, installation instructions and other data to show compliance with requirements of this part of specification and contract documents. Protective treatment for concrete. Contractor shall submit samples of all materials to be used in works before delivery of metal to site. Samples of membrane waterproofing shall be 300 mm square. Samples of liquid components shall be a minimum of 1 liter. Contractor shall submit comprehensive test results for protective coating system according to test specifications, which shall clearly indicate whether values are meant or mean values measured in current production or minimum values which property does not fall below. Contractor shall clearly state chemical composition of materials and process by which protection is given to concrete. In addition to test methods identified in this clause of the specification, engineer may require contractor to carry out further tests to different standards. If contractor wishes to propose a material which has been tested to alternative standards, contractor shall submit correlation tests showing comparable values of two test methods. These test results shall be comprehensive, giving full details of sample conditioning, preparation, method of test, criteria for assessment, etc. Contractor shall submit comprehensive confirmation of previous applications of material in similar conditions and environments. This information shall include project name, type, grade of material used, quantity of material used, name of client, name of consultant, name of contractor. If requested by engineer, contractor shall supply contact details of client, consultant or contractor where material was previously installed. Contractor shall submit a guarantee for protective coating system and workmanship. Guarantee shall be worded to reflect required performance of material and be approved by engineer. Guarantee shall be worded to include a phrase, contractor shall at convenience of employer effect all repairs and replacements necessary to remedy defects, all complete satisfaction of engineer. Unless stated otherwise in contract specific documentation, performance guarantee shall be for a period of 10 years except for penetrative primer, which shall be for a period of 5 years. Use of alternative may be considered by engineer if contractor wishes to propose such systems. A technical submission shall be made which include a comprehensive justification giving an explanation of why proposed system is equivalent or superior to one designated or demanded. Quality requirement. Protective coating system shall be supplied by manufacturer who is certified to be ISO 9000 series of quality standards. Contractor shall submit to engineer a copy of ISO 9000 series certificate that clearly states scope of certification, and this certification should be through registered agency because ISO 9000 cannot directly certify. Protective coating system shall be supplied by a manufacturer who provides technical assistance on suitability of application, suitability for application and installation of material. For initial use of material on site, contractor shall arrange for technical representative of manufacturer to be present to demonstrate correct use of material. Protective coating system shall be applied by a contractor or subcontractor who is certified to system ISO 9000 series through agency of quality standards. The contractor shall submit to engineer a copy of the certificate, agency certificate that clearly states scope of certification. To engineer may permit certification. Engineer may permit of this contractor shall submit to engineer a copy of this certification that clearly states scope of certification. Engineer may permit use of an applicator who is not certified. So, if applicator works to quality system that is approved by engineer, work shall be executed by an approved specialist subcontractor having a minimum of 5 years successful experience of installation of specified material. Only tradesmen experienced with installation of material specified shall be used. Tradesmen experienced with installation of materials specified shall be used. Pre-installation and coordination. Pre-installation and coordination. Sorry. God. After approval of a material and before installation, a pre-work conference with engineer shall be held at site. Meeting shall be attended by representatives of engineer, contractor, subcontractors and manufacturer. Parties shall review drawing specifications, the approved material, correct conflicts if any or whatever between approvals and specification requirements, examine site conditions including inspection of substrata materials, labels and methods of storing materials, review installation procedures and scheduling, review protection methods of finished work from other trades. Before applying coating system to permanent works, contractor shall carry out a small trial of coating system for review and approval of engineer. Delivery, storage and handling. Materials shall be delivered in their original tightly sealed containers or unopened packages, all clearly labeled with manufacturer's name, brand name and number and batch number of material where appropriate. Materials and equipment shall be stored as directed in a neat and safe manner. The storage area shall comply with manufacturer's requirements with regard to shade, ventilation and temperature limits and shall be located away from all sources of excess heat, sparks or open flame. Containers of liquid material shall not be left open at whatever time in storage area. Materials not conforming to these requirements will be rejected by engineer and shall be removed from site and replaced with approved material. Contractor shall deliver materials to site in ample time to avoid delay in job progress and at such times as permit proper coordination of various parts. Protection. Contractor shall protect the system installation from damage during construction period so that it will be without any indication of abuse, defects or damage at time of completion. Contractor shall protect building structure from damage resulting from spillage, drippings and dropping of materials. Contractor shall prevent whatever materials from running into and clogging drains, Materials and plants shall not be stored on whatever newly constructed floor without permission of engineer. Impervious membrane shall be laid for protection to all concrete surfaces in contact with soil and shall consist of tanking or similar accepted material based on soil investigation report. All foundations shall be provided with protection such as epoxy coating or similar other accepted equivalents so that concrete is not exposed to harmful effects of soil, chlorides, etc. General requirements for all treatments. Protective treatment shall be applied where designated in contract specification document. All protective coating system to be used shall be applied strictly in accordance with manufacturer's recommendations. Contractor shall take all necessary precautions against fire and other hazards during delivery, storage and installation of flammable materials specified herein and comply with regulations imposed by Civil Defense Department of Ministry of Interior in respect of storage and use of hazardous materials required under this section. Engineer shall specify required final color of coating and contractor shall submit samples showing color before ordering materials. Final inspections. Upon completion of installation, an inspection shall be made by a representative of material manufacturer in order to ascertain that system has been properly installed. Epoxy coating. Coating shall be decorative flexible high solids epoxy polyurethane coating applied in two coats to a dry film thickness of 200 micrometer minimum. Surface preparation. Surface of concrete shall be free from oil, grease, loose particles, decayed matter, moss or algae growth and general curing compounds. All surfaces contamination and surface laitance shall be removed by high pressure water jetting or sweep blasting. Blowholes and areas of substantial pitting shall then be filled with solvent-free thixotropic epoxy resin fairing to coat. Mixing and application of this coat shall be in accordance with product manufacturer's recommendation for purpose of cleaning original surface. Etching can be allowed with 10% hydrochloric acid if it is possible. Etching which has to be washed immediately and then application of this coating done. Where surface cracking is apparent, this crack shall be chased by an approved mechanical means to the depth of crack. The thixotropic epoxy resin shall be applied using a trowel scraper or filling knife, ensuring that full compaction is achieved into chased section and providing a flush finish with concrete surface. A minimum period of 24 hours shall be allowed before applying any subsequent protective coating system. Materials. External above ground coating materials shall provide protection against chlorides and carbonation and be ultraviolet and abrasion resistant. Above ground coating shall be applied over below ground coating and shall continue for a minimum of 150 mm above ground level. Epoxy coating shall be UV ultraviolet stable. Finished coating shall be pinhole free and have a total minimum dry film thickness of 200 micrometer. Materials used in coating system shall comply with following requirements: solid content greater than 85%, service temperature -20 degrees Celsius to +70 degrees Celsius, tensile strength DIN 53504 4 MPa, resistance against crack DIN 53515 6 MPa, adhesion to concrete ASTM D4541 greater than 3.5 MPa, compressive strength ASTM D695 90 MPa, neat resin, tensile elongation ASTM D638 6 to 8% neat resin, water absorption MILD 24613 nil, Abrasion resistance ASTM C50150 mg. Compressive strength ASTM C57997 MPa at 7 day. Thermal coefficient of expansion ASTM C531 46.8 into 10 to the power minus 6 mm per degree Celsius. Application. Where required by engineer, trial areas not exposed and finished work shall first be treated using selected material. Exposed concrete surfaces as defined in documents or as agreed with engineer shall be treated with material. Coating shall be applied by spray roller or brush to achieve a finish acceptable to engineer. In all operations of storage, mixing and application, contractor is to comply with health and safety recommendations of manufacturer and governing authorities. Waterproof membrane. This subpart covers use of waterproof membrane for general protection to buried concrete. Where indicated on drawings or directed by engineer, concrete in contact with ground shall be protected by a preformed, flexible, self-adhesive bitumen type membrane. Laying, lapping, and sealing of membrane shall be in accordance with manufacturer's instructions. Materials. Material shall be an externally applied waterproof membrane should be an impervious cold applied flexible laminated sheet consisting of multi-layer high-density cross-laminated polyethylene film with a backing of self-adhesive rubber bitumen compound protected with silicone-coated release paper. I repeat this very complicated technical sentence. Material shall be an externally applied waterproof membrane. Externally applied waterproof membrane shall be impervious cold applied flexible laminated sheet. Impervious cold applied flexible laminated sheet consisting of multi-layer high density cross-laminated polyethylene film. Cross-laminated polyethylene film with the backing of self-adhesive rubber bitumen compound protected with silicone coated release paper. Primer for sheet membrane as recommended by manufacturer for sheet membrane protection board. Provide a minimum 6 mm thick asphalt protection board manufactured from selected aggregates bound in modified bitumen encased between two layers of strengthened asphalt paper. Bituminous material shall be a minimum of 1 mm thick and membrane shall be capable of bridging crack widths in substrate up to 0.6 mm wide. Waterproof membrane. Material shall be suitable for use in Gulf region. Compound shall be specially formulated for hot climates and have proven experience in Middle East. Waterproof material shall conform to standards detailed in Table 14.1, and these are waterproof membrane property requirements. Just a minute. Let me take some. Elongation film ASTM D638 longitudinal 210% to 10%, transverse 160% elongation of this film. Tear resistance ASTM D1004 longitudinal 340 MPa, transverse 310 MPa. Adhesion to primed concrete ASTM D1000 1.8 MPa, elongation compound ASTM D1000 1.8 MPa. Puncture resistance ASTM E154 220 Newton or 65 mm. Water resistance ASTM D570 after 24 hours 0.14%, after 35 days 0.95%. Environmental resistance ASTM D543. Moisture vapor transmission rate ASTM E96 0.3 gram per meter square 24 hours. Minimum thickness 1 mm. Application. Waterproof membrane placed on vertical concrete faces shall be protected by preformed asphalt board. We have talked of already. Both shall be bonded onto position with high quality solvent bond contact adhesive based on polychloroprene rubber. Concrete shall coordinate installation of waterproofing membrane with flow drain equipment based on other adjacent work and mask adjacent work to prevent soil marks. Areas where waterproofing is applied shall be protected from all traffic and wherever necessary backfilling. All damage to finished portion of waterproofing membrane shall be either repaired or replaced or both in a manner acceptable to engineer. Penetrative primer. System shall be penetrating hydrophobic treatment that protects concrete from both water and chloride intrusion while permitting water vapor transmission. Treatment shall significantly reduce absorption of water and waterborne salts but allow transmission of water vapor from substrata. Treatment shall not produce any discoloration of surface or substrata and shall have excellent resistance to weathering. Material. Material shall be a low viscosity silane silicone system. Silane, that is low viscosity. Material shall be a low viscosity silane siloxane system which penetrates deeply into porous substrata and reacts to produce a bonded hydrophobic lining to pores. Material shall be resistant to petrol, oil and atmospheric contaminants such as car exhaust fumes and industrial exhaust. Surface preparation. Surface shall be dry, free from oil and grease, loose particles, decayed matter, algae growth and curing compounds. If concrete surface is newly cast and has a very smooth finish, surface shall be roughened by sand or grit blasting, water blasting or some mechanical means. Engineer shall decide if this means of preparation is required. Moss or algae growth of surface shall be removed using a proprietary fungicidal wash in accordance with manufacturer's recommendations. Concrete finishing required shall be completed before application of treatment. Crack of width greater than 0.2 mm shall be filled in accordance with manufacturer's recommendation. Application. Unless directed otherwise by engineer, the treatment shall be applied a minimum period of 24 hours after wet curing period and shall be surface dry. Contractor shall carry out tests to verify depth of penetration of material. These tests shall be carried out on a specimen of actual mix design and shall use colored dyes to trace penetration of material. Where fine cracking has occurred in concrete at a width not greater than 0.3 mm for reinforced concrete and 0.2 mm for water retaining structure, additional 4 stripe coats of treatment shall be applied before main treatment. Application of material on surfaces shall be done by a low pressure spray direct from can. Under no circumstances should thinning of material be carried out. Rate of application shall ensure that surface is completely saturated. Impregnated coating shall be applied to 2 or more flood coats. Each flood coat shall be a minimum of 0.4 liter per meter square. Material shall be applied strictly in accordance with manufacturer's instructions and as follows. Material shall be applied by a fine nozzle spray. Application will not be permitted when ambient temperature is about 35 degrees Celsius or in windy conditions. Surface shall be cleaned by a stiff brush for compressed air to remove all loose deposits. Concrete to be treated shall be surface dry for a minimum period of 24 hours before impregnation. Membranes, joint sealants, sealers and cast in concrete ancillaries shall be masked off before treatment. Application shall be made by saturation flooding. Interval between applications shall be at least 6 hours. Treated area shall be protected from seawater and rain for 6 hours after treatment. Protective coating. The previous was, this was application of surface preparation. Now we are going to do protective coating. Protective coating. Coating systems shall be used for protection of new or existing reinforced concrete structures against carbonation or chloride induced corrosion. Systems shall comprise of penetrating reactive primer and an acrylic polymer top coat system to minimize ingress of acidic gases, chlorides and water. I repeat, coating systems shall be used for protection of new or existing reinforced concrete structures against carbonation or chloride induced corrosion. System shall comprise of a penetrating reactive primer and an acrylic polymer top coat system to minimize ingress of acidic gases, chlorides and water. Surface preparation. Before application, all surfaces must be dry and free from oil, grease, loose particles, decayed matter, moss or algae growth and general curing compounds. All such contamination and latent must be removed by use of grid blasting, high pressure water jetting, or equivalent mechanical means. Before proceeding to apply protective coating, all surfaces which are not to be coated but which may be affected by application of coating shall be fully masked and in particular flora and fauna be protected. Blowholes and areas of pitting shall be made good with 1 part modified cementitious material and allowed to cure in accordance with manufacturer's recommendations. In particular, application shall be in accordance with manufacturer's recommendations with respect to maximum application thickness. Materials are required to provide in-depth protection against carbonation and chloride penetration whilst permitting water vapor transmission from concrete. Primer shall be a low viscosity siloxane system. Primer shall be low viscosity siloxane system which penetrates deeply into a porous substrata and reacts to produce a bonded hydrophobic lining to pores. Material employed for coating shall comply with following requirements: wet film thickness 400 micrometer, dry film thickness 200 micrometer. Carbon dioxide diffusion resistance R value at 325 microns greater than 161 meters. Taiwood Engineering Laboratories water vapor transmission, that is carbon dioxide diffusion resistance. Taiwood Engineering Laboratories water vapor transmission. Taiwood Engineering Laboratories shall be more than 113 gram per meter square day. Reduction in chloride ion penetration 94% minimum at 28 days. BS 188 part 1 to 4, that is. Tear resistance ASTM D624 7.3 kN per mm square. Cracking bridging BRE method 5.1 mm. Chloride ion diffusion Taiwood Engineering Laboratory 3.63 to 10 to power minus 10 cm square per second. Where test methods are not specified, procedure for establishing compliance with above criteria shall be agreed with the engineer. Contractor is required to adhere strictly to manufacturer's recommendations regarding use, storage, application and safety rules in respect of approved materials. Application. Where required by engineer, trial areas not exposed in finished work shall first be treated using selected materials. These trial areas shall be noted on drawings and be carried out using type of materials. Mixing procedures and applications that be used on contract and approved by engineer before contractor commences with general work. Exposed concrete surfaces as defined in documents or is agreed with the engineer shall be conditioned by application of a penetrating hydrophobic treatment. Primer shall be allowed to dry in accordance with manufacturer's requirements. Contractor shall then apply 2 coats of pigmented top coat in accordance with manufacturer's instructions. Finished coating shall be pinhole free and have a total minimum dry film thickness of 150 micrometers. Color and finish to be agreed with engineer. Coating shall be applied by spray, roller or brush to achieve a finish acceptable to engineer. In operations of storage, mixing and application, contract shall comply with health and safety recommendations of manufacturer and governing authorities. Plastic sheet liner for concrete structures. General. Subpart covers supply and installation of sheet liners in reinforced concrete structures. Liners must be continuous and free of pinholes both across joints and in liner itself. All works for and in connection with installation of lining in concrete pipe and structures and field sealing and welding of joints be done in strict conformity with all applicable specifications, instructions and recommendations of lining manufacturers, shop drawings and submittals. Contractor shall submit to engineer for approval following: liner schedule, material certification, test results, material samples. Manufacturers of lining shall submit an affidavit attesting to successful use of its materials as a lining for sewer pipes and structures for a minimum period of 5 years in service conditions recognized as corrosive or otherwise detrimental to concrete. Liner material requirements. Sheet liner shall be manufactured from high molecular weight PVC or PE, PVC is polyvinyl chloride or polyethylene resin, and other components necessary to make a material of permanent flexibility suitable for a liner in concrete pipes and structures in sewage service. Weld strips and joint strips shall be made from like material. For PVC and PE sheet liners, actual resin used in manufacture must constitute not less than 99% of resin used in formulation. Copolymer resins shall not be permitted. All plastic sheets, including locking extensions, all joints and welding strips, shall be free of cracks, as asperities and other defects that may affect protective properties of material. Properties of PVC and PE sheets are shown in table 14.2. This is 42 properties of PVC and PE sheet liners. Property test methods requirements. PVC elongation at break is ASTM D638 882 300%. Tensile strength ASTM D6 to 15 MPa. Low temperature brittleness ASTM D746 0 degrees Celsius. Polyethylene elongation at break ASTM D638 82 exceeds 600%. Tensile strength ASTM D638 10 to 20 MPa. Low temperature brittleness ASTM D746 minus 75 degrees Celsius. Plastic sheet liner strip properties. Accepted shop welds. Accepted shop welds. All plastic sheet liners and strips shall have properties shown in table 14.3 when tested at 25 degrees Celsius. Properties of plastic sheet liner strips. Property and requirement: tensile strength 15 MPa, elongation at break 200%, short 0 meter, 1s 1 second, 15 to 60 plus minus 5 with respect to 10 seconds, 35 to 50 plus minus 5, weight change plus minus 1.5%, Basic sheet dimensions. Minimum thickness of material shall be shown in table 14 for basic sheet dimension. Plastic sheet liner minimum dimensions, material thickness, structures, sheet with locking extensions 4 mm, sheet plain 2.3 mm, joint stiff 1.9 mm, weld stiff 2.4 mm. Liner details, locking extensions T-shaped shall be of same material as that of liner and be integrally extruded with sheet. Locking extension be approximately 65 mm apart and at least 10 mm high. Sheet not used for shaft fabrication into larger sheets be shaft tested for pinholes using an electrical spark tester set at 9000 volt per 1 mm thickness of lining minimum. Holes shall be repaired and retested. Installation of lining, including preheating of sheets in cold weather and welding of all joints, shall be performed in accordance with recommendations of manufacturers. This is installation of protective treatment of concrete. Lining to be held snugly in place against inner forms by means of steel banding straps or other means recommended by manufacturer. Concrete that is to be poured against lining shall be vibrated, spaded or compacted in a careful manner to protect lining and produce a dense, homogeneous concrete securely anchored locking extension into concrete. In removing forms, care shall be taken to protect lining from damages, in particular. Sharp instruments not to be used to pry forms from lined surface. When forms are removed, nails that remain in lining to be pulled without tearing lining and resulting holes clearly marked. From tie holes to be marked before ties are broken off and all areas of serious abrasion or damage be marked. All nail and tie holes and all cut, torn and seriously abraded areas in lining shall be patched as follows. Patches made entirely with welding strip to be fused to liner over entire patch area. Larger patches may consist of smooth liner sheet applied over damaged area with adhesive. All edges must be covered with welding strip fused to patch and sound lining adjoining damaged area. Hot joint compounds such as coal tar shall not be poured or applied to lining. Contractor shall take all necessary measures to prevent damages to installed lining from equipment and materials used in or taken through work. Testing requirements. Samples taken from sheets, joints or weld strips shall be tested to determine materials properties. Determination of tensile strength elongation shall be in accordance with the STDM. STMD 412 using die B. Determination of determination of indentation hardness shall be in accordance with ASTM 2240 using a type D durometer, except that a single thickness of material and indentation hardness be made of 25 mm by 75 mm specimen. Thickness of specimen shall be thickness of sheet or strip. Measurement of initial physical property for tensile strength, weight, elongation and indentation hardness shall be determined before chemical resistance tests. Chemical resistance tests shall be carried out to determine physical properties of specimen after exposure to chemical solutions. Test specimen shall be conditioned to constant weight of at 43 degrees Celsius before and after submersion in solutions detailed in table 14.5 for a period of 112 days, 112 days at 25 plus minus 3 degrees Celsius. Now Volumetric percentage of concentrated reagents of CP grade at 28 days intervals. Specimen shall be removed from each chemical solution and tested. If specimen fails to meet 112 or 112-day exposure, material will be subject to rejection. Pull test for locking extensions. Liner locking extensions embedded in concrete shall withstand a test pull of at least 18 kN per meter. Applied perpendicularly to concrete surface for a period of 1 minute without rupture of locking extension or withdrawal from embedment. This test shall be made at a temperature between 21 degrees Celsius to 27 degrees Celsius inclusive. Sharp weld joints used to fuse individual sections of liner together be at least equal to minimum requirements of liner for thickness, corrosion resistance and impermeability. Welds shall show no cracks or separations and be tested for tensile strength. Tensile strength measures across welded joints in accordance with ASTM D412 using die B would be at least 15 MPa. Test temperatures be 25 plus minus 3 degrees Celsius and measured minimum width and thickness of reduced section be used. Spark test. All liners be sharp tested for holes with a spark tester set to provide from 15,000 to 20,000 volts. Sheets having holes will be satisfactorily repaired in shop before shipment from manufacturer's plant. Contractor shall provide engineer with certified copies of test reports before shipment of product to site. Chemical resistance test. Chemical solution concentration. Sulfuric acid 20% concentration, sodium hydroxide 5% concentration, ammonium hydroxide 5% concentration, nitric acid 1% concentration, ferric chloride 1% concentration, soap 0.1% concentration, detergent linear alkyl benzyl sulfonate or LAS 0.1% concentration, bacteriological BOD biochemical oxygen demand not less than 700 mg per liter concentration, and phosphoric acid 50% concentration. Special requirements. Liner sheets to be closely fitted and properly secured to inner forms. Sheets that are to be cut to fit curved and warped surfaces use a minimum number of separate pieces. A 50 mm wide water resistant tape or welding strip be welded on back of butt joints to prevent wet concrete from flowing around edges. Unless otherwise shown on drawings, lining be returned to at least 75 mm at surfaces of contact between concrete structure and items not of concrete, and same procedure be followed at joints where type of protective lining is changed or new work is built to join existing unlimited concrete. At each returned liner be sealed to item in contact with plastic lined concrete with an adhesive system. If liner cannot be sealed with this adhesive because of joint at return being too wide or rough, or because of safety regulations, joint space shall be densely caulked with lead wool or other approved caulking material to a depth of 50 mm and finish with minimum of 25 mm of an approved corrosion resistant material. Joints in lining for in situ concrete structures. Field joints and lining at joints shall be free of all mortar and other foreign materials and be clean and dry before joints are made. All welding to be in strict conformance with the specifications of lining manufacturer. Testing and repairing damaged surfaces. All surfaces covered with lining, including welds, be tested with an approved electrical holiday detector with instruments set at 9000 volts per 1 millimeter of lining minimum. All welds be physically tested by a non-destructive probing method. All patches, overhauls or repairs to liner wherever damage has occurred. Each transverse welding strip which extends to lower edge of liner be tested by an approved testing agency at cost of contractor. Welding strip shall extend 50 mm below liner to provide a tab. A 5 kg pull be applied to each tab. Force be applied normal to face of structure by means of a spring balance. Liner adjoining welding strip be held against concrete during application of force. 5 kg pull be maintained if a weld failure develops until no further separation occurs. Defective weld be retested after repairs have been made. Tabs be trimmed away neatly by installer of liner after welding strip has passed inspection. Inspection be made within 2 days after joints have been completed in order to prevent tearing, projecting weld strip and consequent damage to liner from equipment and materials used or taken through work. हाँ बंटी, बुखार को गोली ला के दी। डॉक्टर साहब से बात हुई थी कि गोली मंगाई थी उन्होंने, कौन सी मुझे तो पता नहीं, ला के दी थी इसने गोली। अभी पता नहीं उतरा नहीं उतरा, देखेगा अभी ऊपर गया कहाँ गया मालूम नहीं। माँ उनसे बात हुई डॉक्टर कुलदीप से, तो उन्होंने कहा था गोली कोई पता कौन सी गोली कहा था मुझे तो मालूम नहीं है।
अच्छा,
तो देखते हैं, बता देंगे, नहीं तो कल फिर टेस्ट तो कराना ही पड़ेगा। अभी तो है, पता नहीं कहाँ गया है मालूम नहीं, बाहर गया कि ऊपर गया है। हाँ मेरे ख्याल हॉल में है शायद। अब यहाँ से पता लगता नहीं ना कौन कहाँ है। अभी कहाँ गई है आइसोलेशन में, आज तो बाहर थी उधर रिलेटिव के हॉल में। अभी उसको ला के दी थी ना, तो आज व्रत भी है वैसे भी उसका। तो उसने डॉक्टर साहब से बात की थी, कोई गोली उन्होंने लिख के दिया था, वो लाया है, वो अभी खिलाई है, पता नहीं अभी कितना बुखार उतरा नहीं उतरा। तो अभी देखेंगे। हाँ क्या चीज़? अभी पता नहीं ना उसका बुखार उतरा कि नहीं उतरा, देख तो लें। अभी दिया गोली, अगर नहीं उतरा होगा तो फिर देखेंगे, कराना पड़ेगा। अभी उससे से बात हुई है, डिटेल में मुझसे बात नहीं हुई थी ना। उसी लड़के से बात हुई थी, मैं कट गया था, बाद में उन्होंने खुद ही बात की थी। पूछ लिया उनसे लड़के से क्या कर रहा है। अब मैंने थोड़ी डिसाइड करना है यार, अगर वो नहीं उतरेगा तो कराएंगे कराएंगे। अब बुखार उन्होंने कहा, उन्होंने क्या कहा है ना उससे मुझे नहीं पता। हाँ तो करवा लेंगे, मैं मना थोड़ी कर रहा हूँ। नहीं नहीं, काम मंदिर का तो सुबह गई थी, उसके साथ थोड़ी देर में पता नहीं क्या क्या किया मुझे नहीं पता। यहाँ तो वही रोटी बना के गई थी दिन में जी। हाँ वो बना के गई थी, अब रात को आएगी, फिर आएगी, पता नहीं कब आएगी। अभी दाल बना के गई थी, रोटी बना के गई थी। बुलाया तो उसको आ गई थी, लगाएगी रात के आऊँगा, आऊँगी, अभी तक तो आई नहीं, कब आएगी पता नहीं। वो तो कर रही है काम, वो तो दिक्कत नहीं है। तो सुबह सुबह आ जाएंगे तो नहीं हो पाएगा ना, ना तो नहाई होगी ना कुछ हुआ होगा। हाँ तो बुक करा दे, देख लेंगे क्या होता है, करा लेंगे तो करा लेंगे। अब पता नहीं ना कैश कितना पड़ा क्या पड़ा, देखें, मुझे तो मालूम नहीं कितने पैसे उसके पास, देने भी तो पड़ते हैं ना लोगों को पैसे। अब करा लेते हैं, देखा जाएगा यार, शाम के टाइम में आ जाएगा, कर लेगा। खाया भी कुछ, खाना भी तो होना चाहिए ना उसमें, शाम तक तो खाएगी कुछ नहीं है। जब तक पूजा वूजा करते नहीं खाते भी तो नहीं है कुछ ये। आज तो व्रत है, अभी तो कुछ भी नहीं खाया, चाय पिए बस उसने। अब अभी बनेगी रात को तभी खाएगी ना। अरे बनती है, बोलने से किसी की मानी जाती है क्या? अगर इतना आसान होता तो अब तक मैं ही ना लड़ लेता उससे, ये बता। देख ले, कल नहीं तो परसों हो जाएगा, इतना ही है, और कितना फर्क पड़ेगा। हाँ तो डिले हुआ तो बता क्या करूँ मैं। यार मैं क्या करूँ, मैं तो जाम हो गया मैं एक जगह। अरे टेबलेट दी है, मुझे पता नहीं उससे उतरा नहीं उतरा, मैं कैसे कह दूँ, मुझे इन्फॉर्मेशन नहीं है। अभी नहीं दिए, कई घंटे पहले दिए, ये लाया था 2-3 घंटे पहले लाया था। उससे जाके अभी गया था बाजार दिन में, जो उन्होंने बताई थी ना डॉक्टर कुलदीप ने। पहले ये कह रहा था इंजेक्शन, उन्होंने इंजेक्शन को मना कर दिया था। तो इंजेक्शन मत लगा, वो ये टेबलेट लिया, वो टेबलेट ला के उसने दी है। अब उससे कितना उतरा नहीं उतरा मुझे पता नहीं है। या तो उस लड़के से खुद बात कर ले, इसी लड़के से, इसी यस से। हाँ तो वो क्या कह रहा है वो, कर ले बात, मुझे क्या पता, कर ले। नहीं तो उसको डॉक्टर कुलदीप को तो नहीं पता ना कि वो उतरा है कि नहीं उतरा बुखार, उनको तो नहीं पता ना। अब मेरे को पता नहीं यार, उतरा नहीं उतरा, वो बताएगा तभी तो पता लगेगा। मैं सब समझ रहा हूँ यार, बेवकूफ़ नहीं हूँ, लेकिन अब उस गोली खाने के बाद क्या हुआ मुझे क्या पता। गोली खाने के बाद कितना कम हुआ है मुझे तो नहीं पता ना। वो तो पहले से ही है ना, आज से थोड़ी है। वो तो पहले से ही है, 99 कभी, अब सुबह 97 था, फिर 99 हो गया। हाँ। अरे भैया इरेगुलर है क्योंकि उसकी बॉडी इरेगुलर है, बुखार क्या करेगा उसको, वो खुद ही इरेगुलर है, दिमाग इरेगुलर है। तो देख ले यार, बात कर ले लड़के से, अगर जरूरत है तो कल करा लेंगे, नहीं तो हाँ। हाँ पूछ ले, पूछ ले। क्या करूँ मैं, हर की अपनी अपनी प्रॉब्लम है। Sorry, gentlemen, concrete, hot weather concrete is very important chapter, part 15, hot weather concrete, because hot weather is very, very critical, in particularly in our country as well as Gulf country. So hot weather concrete must be given due attention, and if you neglect this, you neglect engineering, remember. And if you neglect engineering, you are responsible, nobody else is responsible. Hot weather concreting, general scope references, definition of hot weather system, description, submission, placing, temperature, planning, concrete mix design, temperature control, general aggregates, water, cement, addition of ice, liquid nitrogen, batching and mixing, transportation, placing and finishing, curing and production, inspection and testing. So hot weather concrete, let's start this in general. This part covers precautions to be taken for hot weather concrete for all structural concrete except blinding concrete, where a minimum compressive strength is specified. Part 6 is property requirements. Part 7 is concrete plants. Part 8 transportation and placing of concrete. Part 10 is curing. ACI 305 or 91. American Concrete Institute hot weather concreting. ASTM C106 for measuring temperature of concrete. BSEN 1992-1-1 Serial Code 2 design of concrete structure, general rules and rules for buildings. BSEN 480 admixtures for concrete mortar and grout test methods. BSEN 9 admixtures of concrete mortar and grout. The definition of hot weather is very important part we are starting with now. Requirement of following clauses of specification are applicable during hot weather period in Qatar. So it's for whole Gulf you can say hot weather period shall be defined as a starting when minimum ambient air shade temperature on site exceeds 35 degrees Celsius. That is datum line you can say. For 3 consecutive days, end of hot weather period be defined as period when maximum air shade temperature is below 35 on 3 consecutive days. Contractor shall establish a thermometer on site that records ambient air shade temperature. Thermometer be established at the position to provide representative air temperature for site conditions. If requested by engineer, contractor shall arrange for calibration of site thermometer. Hot weather means combination of following conditions that tends to impair quality of freshly mixed or hardened concrete by accelerating rate of moisture loss and rate of cement hydration, or otherwise causing detrimental results such as high ambient temperature when shade temperature is above 40 degrees Celsius on a rising thermometer, 43 degrees Celsius on a falling thermometer, high concrete temperature, low relative humidity, high wind speed, rate of evaporation exceeds 0.75 kg per meter square per hour. System description. System description. Contractor shall undertake hot weather concreting procedures that are effective in controlling following potential problems associated with concreting in hot weather: increased water demand of mix, increased rate of slump loss, increased rate of setting, increased tendency for plastic shrinkage cracking, decreased long-term strength, increased tendency for drying shrinkage and cracking, increased tendency for differential thermal effects with consequent cracking, decreased durability from cracking where there is increased permeability. Submittals. Contractor shall prepare weekly in advance his proposed concreting program showing quantities to be placed and anticipated placing hours. At least 1 month before the start of hot weather period, contractor shall submit specific proposals for control of concrete temperature for constituent materials, cement, water, aggregate. Where required, contractor shall submit to engineer proposals for use of liquid nitrogen for cooling, which include details of previous project application and intended methods to be used and quantities of liquid nitrogen. Placing temperature. Subpart of specification applies to all times of year and all times of day. Maximum fresh concrete temperature at placement shall not exceed 32 degrees Celsius unless construction testing to verify a proposed concrete mixture shall function satisfactorily at a concrete temperature greater than 32 degrees Celsius. No concrete shall be placed if concrete temperature is above 35 degrees Celsius. Concrete shall not be placed if shade temperature exceeds 40 degrees Celsius. Temperature of each truck of concrete shall be measured using either a glass, dial type or electronic thermometer. Just before placing of concrete and temperature recorded on delivery ticket. Maximum temperature at placing apply to entire load of concrete in truck or conveyor. Contractor shall allow for increase in the concrete temperature in period from dispatch from plant while in transportation or whilst waiting placement on site, and take adequate measures to ensure maximum temperature is not exceeded. Planning concrete. During hot weather period as defined in clause 15.13 Wait a minute, please. Yeah. हाँ हेलो. हाँ.
मैंने इनका कल का टेस्ट बुक करा दिया है कोविड का.
कितने बजे?
ये 1:30 करीब आएगा.
तो 1:30 बजे तो भूखी होगी है.
तो उससे क्या फर्क पड़ता है?
चलो कह दूंगा मैं उसको.
हाँ तो 1:30 करीब आएगा तो ले जाएगा सैंपल आके देखो फिर.
ठीक है, बोल दूंगा.
हाँ फिर अगले दिन रिपोर्ट आएगी 4 बजे से 5 बजे.
ठीक है.
क्योंकि डॉक्टर कुलदीप कह रहे हैं वो करा लेते हैं ताकि वहम वहम निकल जाए जो भी है.
हाँ.
ठीक है.
ठीक है.
तो मैंने बुक करा दिया है.
हाँ.
तो कल 1:30 मतलब इनको बता देना कि जैसे भी तैयार रहेंगी. ठीक है.
ठीक है. ठीक है, बोल दूंगा. ठीक. ठीक है. ओके. During hot weather period specified in clause 51.3 of this part, contractor shall plan concreting operations such that no concreting takes place between hours of 10 hours and 5 hours, 17 hours. 10 hours and 17 hours, no concrete should happen. Practically, that's what is requested. Contractor shall arrange concrete pour such that program of works can be achieved without concreting during period from 10 hours to 17 hours. Contractor shall nominate one member of staff to be coordinator for supply of concrete. Coordinator responsibility shall include ensuring batch rate matches that of delivery and placement and preparations needed before commencing a concrete pour. Mix design. In hot weather period, contractor shall review all concrete mix designs to ensure that design slump or workability specified is achieved without increase in mixed water content. Contractor shall make modifications to mix design to allow for increased slump loss during transportation in hot weather. This shall be achieved by adjusting proportion of admixture, plasticizer or super plasticizer. Permitted range of admixture shall be clearly stated on concrete mix design with nominal values for cold weather and hot weather use. Under no circumstances, addition of extra water that increases water cement ratio be permitted during hot weather. All concrete material and the proportions used in periods of hot weather shall be those that have a satisfactory records of use in such conditions. Temperature control general. Contractors' specific proposals for control of concrete temperature shall include extent and type of shading of aggregates, method of chilling mixed water, and procedure for batching and mixing, transportation, placing and finishing, curing and protection. These shall include calculations in accordance with ACI 305R Clause 3.1, estimating concrete temperature. Contractor shall calculate temperature of freshly produced concrete based on input temperature of constituent materials and weights from particular mix designs. Calculations shall make allowance for rise in temperature between mixing and placing due to transportation and waiting period. Calculation shall successfully demonstrate that temperature can be maintained below 32 degrees Celsius at point of placing. All practical means shall be applied to keep aggregate as cool as possible. Stockpiles of aggregate shall be shaded from direct sunlight. Shades shall extend beyond edge of aggregate storage areas and stockpiles layout shall be such that direct sunlight is not incident on aggregates. Shades shall be constructed to allow access for mechanical shovels or means of conveyance. Shades and stockpiles shall be constructed so as to permit free flow of air over aggregates. Embedded cooling pipes may also be used to cool aggregate. Sprinkling of coarse aggregate to reduce temperature by evaporation or direct cooling shall not be permitted. Sprinkling of coarse aggregates to reduce temperature by evaporation or direct cooling shall not be permitted. Water. Mixed water shall be cooled by storing in underground tanks or insulated tanks above ground. Mixed water shall be cooled by storing in underground tanks or insulated tanks above ground. Water shall be chilled by use of proprietary chillers or addition of ice to water tanks. Measures be taken to ensure that ice pieces are not inadvertently deposited directly into mixer. Water shall not be chilled below temperature of 5 degrees Celsius. Tanks, pipes or trucks used for storage or transportation of water be insulated and painted white. Mechanical refrigeration equipment and insulated water storage be adequate for anticipated hourly and daily production rates of concrete during hot weather period. Mixing water may also be chilled by injection of liquid nitrogen into an insulated holding tank. Such procedure shall be to approval of engineer. Ice be completely melted in mixing water prior to adding water to mixer. Cement. Use of freshly ground cement at very high temperature is not permitted. Cement shall be kept below temperature which there is tendency of false set. Under no condition shall temperature of cement exceed 75 degrees Celsius when it enters mixer. Contractor shall make arrangements for storage on site to allow cooling of freshly ground and delivered cement. Addition of ice. Crushed, shaved or shipped ice can be used as part of mixing water for reducing concrete temperatures. Mixing nominal size of particles be 10 mm and all ice must be melted before completion of mixing of concrete in pan. To ensure proper concrete mixing, maximum proportion by substitution shall be 75% of batch water requirement. Crushing ice shall be stored at a temperature that will prevent lumps from forming by refreezing of particles. Batching plant shall incorporate a mechanical system for correctly proportioning and weighing ice to be added to mixture. Quantity of ice shall be deducted from total batch water. Contractor shall ensure that there are adequate quantities of ice in suitable refrigerated storage on site at plant to meet anticipated daily and hourly production rates of concrete during hot weather period. Liquid nitrogen. Freshly mixed concrete may be cooled by injection of liquid nitrogen. Care shall be taken to ensure that concrete directly adjacent injection nozzle is not frozen. Use of liquid nitrogen for cooling concrete shall include a nitrogen supply vessel and injection facility for batching plant or one or more injection station for truck mixers. System may be set up at site for injection just before placing. Proper safety precautions as advised by supplier of liquid nitrogen be used. Batching and mixing. Batching and mixing. Drum of concrete mixer trucks shall be painted white to minimize solar heat gain. Where a truck mixer has been left standing in sun, empty drum shall be sprayed with water and drum flushed out with cold water before batching. Care be taken to ensure all water is removed from drum before batching. Temperature of concrete shall be checked after discharge from mixer and written on delivery ticket. Temperature check shall be carried out at plant on concrete floor for every 50 meter cube produced or every hour, whichever is minimum. A water reducing set retarding chemical admixture conforming to requirement of BSEN 480 parts 1, 2 and 4 may be used in varying proportions under different air temperature conditions. Transportation, placing, compaction and finishing of concrete shall be at fastest possible rate. Delivery of concrete to site be properly scheduled to match rate of placement and compaction. Placing and finishing. Temperature of first truck of concrete of a particular pour is above specification. Maximum temperature limit, then placing shall not commence. I repeat, if temperature of first truck of concrete of a particular pour is above specification maximum temperature limit, placing shall not commence. If a pour is in progress and temperature of a particular truck exceeds the maximum permitted temperature, placing may be allowed to continue at discretion of engineer in order to avoid possible development of a cold joint. However, no further concreting course shall take effect until contractor has submitted revised calculations in accordance with ACI 305R clause 3.1 to demonstrate that maximum temperature shall not exceed in future. Before beginning new pours, temperature of concrete constituent materials shall be monitored to verify that they meet assumptions of calculation. Curing and protection. Curing and protection shall conform the requirements of Part 10 of this section. Evaporation shall be minimized, particularly during first few hours subsequent to placing concrete by suitable means such as applying moisture by fog spraying or some other means acceptable to engineer. Inspection and testing. All thermometers used for measurement of concrete temperature shall be calibrated weekly against glass mercury thermometer. Calibration shall be carried out over temperature range of 10 degrees Celsius to 100 degrees Celsius using a water bath with ice or heating. Method used to determine acceptance of temperature controlled concrete should be in accordance with ASTM C1064. All concrete test specimens for strength or other purposes shall be carefully protected and cured. Specimen shall be protected from accidental damage by plant, personnel or equipment on site. Specimen shall be kept moist by addition of water or covering by suitable curing materials. Exact time of preparation of specimen on site shall be noted and time when it is transferred to laboratory. These times shall be written on test report. Now we are going to miscellaneous, which is also very important point. Miscellaneous, which is very important point from view of controls, and let us see what it says. General scope reference, pavement quality concrete scope, mixed design, cement, water aggregate mixtures, air content, density cementous grout, general metal workmanship, screed scopes, general silver concrete, repair of concrete, general honeycombing of spalling, crack injection, polyester resin concrete, PRC, piping system for non-pressure Drainage and sewerage general resin minimum strength. Now in this miscellaneous general, this part deals with miscellaneous items related to concrete works, including pavement, quality concrete, no fines concrete, lightweight concrete, cementitious grout, screeds, repair of concrete and grouting. And relation is part 2 aggregate, part 3 cementitious material, part 4 water, part 5 admixture, part 6 property requirements, part 7 concrete plants, part 8 transportation and placing of concrete, part 9 formwork, part 10 curing, part 15 hot weather concreting. References are ACI 506 Guide to Shortcrete, Guide to Shortcrete, ASTMC 98910, Standard Specification for Slag Cement for use in concrete and mortars, BS 146 Portland Blast Furnace Cement, BS 812 Testing Aggregate, BS A1881 Testing Concrete, BS 2782 BS 2782 Methods of Testing Plastics, BS 3892 Pulverized Fuel Ash, BS 44551 Methods of Testing Mortars, Screeds and Plasters, BS 5075 Concrete Admixtures, BS 6319 Testing of Resin and Polymer, Cement Compositions for use in construction, BS 6610 Specifications for Pozzolanic Pulverized Fuel Ash Cement, BS 8203 Code of Practice for Installation of Resilient Floor Coverings, BS 8500 Concrete, BS EN 1971 Cement Composition, Specifications and Conformity Criteria for Common Cements, BS EN 480 Admixtures for Concrete, Mortar and Grout, Test Methods Part 1 to 5, 4, 5, 6, 8, 10, 11 and 12, BSCN 934 Admixtures for Concrete, Mortar and Grout Part 2 and 6, BSEN 998 Specification for Mortar for Masonry, and BSEN 17441 Test for Chemical Properties of Concrete, Test for Chemical Properties of Aggregates, Chemical Analysis, BSEN 12350 Testing Fresh Concrete, BSEN 123905 Flexure Strength of Test Specimen, BSEN 12620 Aggregates for Concrete, EN 1974 2004 Cement Composition, Specification and Conformity Criteria for Low Orleans Strength Blast Furnace Cements, EN 1974 Cement Composition, Specifications and Conformity Criteria for Low Orleans Strength Blast Furnace Cements, EN 12350 Testing Fresh Concrete, EN 1744-1 Testing for Chemical Properties of Aggregates, Chemical Analysis, GSO EN 2061 Concrete Specification, Performance, Production and Conformity, SSW 1000 Specification for Highway Works, UK Road Pavements, Concrete Materials, Pavement Quality, Concrete Scope. This subpart covers mixed design for concrete used for aircraft aprons and roadworks as surface slabs, continuously reinforced concrete road base and wet clean mix, except cement bound granular material used as a road base or sub base or as a backfill material for excavation. Mixed designs. Concrete in rigid or composite pavements, one of grades given in table 16.1 below in accordance with pavement design shown on drawings or as directed by engineer. All concrete for use in pavements shall be designed mixes or equivalent standards mixes in accordance with relevant clauses of BS 8500 and BSO EN 2061 except where otherwise specified. Prescribed mixes may be used for rapid construction with the approval of engineer. Pavement grades. This is pavement layer BS 850, 8500 and GSO EN 2061 design mix. BS 8500 and GSO EN 2061 standard mix. Surface slabs. Now unreinforced concrete C40, jointed reinforced concrete JRC C40, continuously reinforced concrete pavement CRCP C40, continuously reinforced concrete road base CRCP CRCR C40, ground anchorage beam C40. Then wet lean mixed concrete 4 C20, and ST4. Then wet lean mix concrete 3 C15 and ST3. When wet lean mix concrete 2 C10 ST2, and wet lean mix concrete 1 C75 7.5 ST1. So this is 1 is 7.5 to C10 3 C15 and C20 1 2 3 4. Now cement, general term cement in this part means material shown below. Cement and complying with cement composition specifications and composition specifications and conformity criteria for common cements EN 1971, Portland blast furnace cement BS146 or EN 1974 is specification for pozzolanic pulverized fuel as cement grades C20 or below BS6610. Use of combination of Portland cement ground gravity blast furnace slag is permitted subject to approval of engineer. In such case, the engineer will stipulate minimum combined cementitious material content required for mix. Use of combination of Portland cement and pulverized fuel ash is permitted subject to approval of engineer. In such cases, engineer will stipulate minimum combined cementitious material content required for mix. PFA shall be in accordance with BS 3892. Use of microsilica in mix design will permitted if approved by engineer. You will stipulate minimum combined cementitious metal content required for mix where PFA or GGBS are used. Maximum proportion of ground granulated blast furnace slags with Portland cement shall be as per table 6.6 of part 5.6. In combination with Portland cement, proportion of PFA by mass to total cement shall be per table 6.6 of part 5.6. Limit of chloride content of concrete shall be as stated in table 6.5 part 5.6. Minimum cement content of concrete pavement shall be pre-approved by Qatar. Standard water for use in marking, making and curing of concrete shall conform the requirements of part 4 of this section. Water content shall be minimum required to provide agreed workability for full compaction of concrete to required density, determined by trial mixes or other means approved by engineer. Aggregates requirement of part 2 of this specification shall govern except as modified below. Aggregates for all pavement concrete shall be complying with BSEN 12620. Alternatively, coarse aggregate of recycled and secondary aggregate material may be used to replace up to 50% by mass of coarse aggregate. Nominal size of coarse aggregate shall not exceed 40 mm when spacing between longitudinal reinforcement is less than 90 mm. Nominal size of coarse aggregate shall not exceed 20 mm. If requested by engineer, contractor shall carry out tests on proposed aggregate combination to check for possibility of alkali silica reaction. Such tests shall be carried out in accordance with procedure laid down in part 2 of this section. Admixtures. Plasticizers of water reducing admixtures shall comply with BS 5075, BSEN 480 and BSEN 934. Admixtures containing calcium chloride shall not be used. Other chloride-free admixtures may be used with approval of engineer. Air content. Total quality of air in air entrant concrete according as a percentage of volume of mix shall be 5 plus minus 1.5% for mixes of nominal aggregate size 20 and be 4 plus minus 1.5% for mixes of nominal aggregate size 40. Air content shall be determined at point of delivery by a pressure type air meter in accordance with BSE 12350-7 at rate of 1 determination per 300 meter square of slab or at least 6 times per day, whichever is greater, in conjunction with tests for workability and strength. For areas less than 300 square meters, rate shall be at least 1 determination to each 20 meter length of slab or less constructed at one time or at least 3 times per day. If air content is outside specified limits, further determination be made immediately on next available load of concrete before discharging. If air content is still outside limit, contractor shall immediately adjust the air content of concrete to improve its uniformity before further concrete is used in work. Air entraining agent shall be added at mixer by an apparatus capable of dispensing correct dose within tolerance for a mixture given in EN 2061, and so as to ensure uniform distribution of agent throughout batch during mixing. Density. Density of concrete grades greater than C30 shall be such that without air entraining, total air voids are not more than 3%. With air entrainment, total air voids shall be not more than 8% for 20 mm aggregate and 7% for 40 mm aggregate. Density of concrete grades B 15 MB 20 mixed ST4 or below shall be less at least 95% of theoretical maximum dry density. Cementitious grout general. This subpart covers a general purpose non-shrink cementitious grout. Grout shall be used to where it is necessary to eliminate shrinkage when filling voids between a base plate and a substrata, such as in grouting of stanchion bases. Anchorage fixing, including masts, anchor bolts, and fence posts. Grout shall be supplied by a reputable construction chemical company as a single pack pre-packaged cement base product which is chloride free. For a particular application, contractor shall submit a method statement detailing how formwork shall be placed and points where grout poured. Before beginning work on large repetitive works, contractor shall arrange for a site trial of materials and methods with suppliers representatives being present to train contractors' personnel in correct use of material. Grout shall be suitable for filling gaps of thickness up to 100 mm and be free flowing and non-shrink. Positive volumetric expansion shall take effect while grout is plastic by means of gaseous expansion to avoid shrinkage and cracking. Compressive strength of grout when tested in accordance with BSEN 12390-3 shall be minimum 25 MPa at 24 hour, 40 MPa at 7 day and 50 MPa at 28 day. Grout shall exhibit a high early strength gain yet not be subject to cracking or other detrimental effect. An ambient temperature about 35 degrees Celsius. Cool water shall be used for mixing grout before placing. Workmanship. Storage, handling and pouring of grout shall be in strict accordance with manufacturer's instructions. Substrata surface shall be free from oil, grease or loose or partially bonded material. If concrete surface is defective or has latents, it shall be cut back to a sound base. Bolt holes and fixing pockets shall be blown clean of dirt or debris. Substrata shall be soaked with fresh potable water before grouting. Although immediately before grouting, free water removed and blown out of bolt holes or pockets. Grout shall not be placed in a gap of less than 25 mm for base plates larger than 1 meter wide. For larger base plates or flow areas, manufacturer's instruction to be followed. Base plates and metallic items shall be clean and free from oil, grease or scale. Vent holes be provided to allow release of air from isolated spots. Formwork shall be made leak proof by use of foam rubber strips or mastic sealant between constructive formwork and joints. Formwork shall extend above required pour height and if necessary shall be extended to allow a hydrostatic head to aid placement. Grout shall be mixed mechanically with a slow speed drill fitted with a high shear mixer. Quantity of water to be added to pre-weighed bags shall be enough to give desired consistency as travelable or flowable. Mixing shall take effect for a minimum of 5 minutes. Grout shall be placed within time limit specified by manufacturer depending on actual application temperature. Grout shall be poured from one side and shall be verified that grout has flowed under all base plate with no voids. Pouring from several sides shall not be permitted. Exposed areas of grout shall be thoroughly cured in accordance with part 10 of this section. Screeds. Screeds. This subpart covers screeds that provide, by means of a layer of mortar, a level surface in flooring applications and to provide falls on flat concrete roof. General screed shall be suitable for application onto concrete substrata. Screed shall be suitable for receiving surface finishes, which may arrange from thin flexible sheeting of ceramic tiling. Screed is not intended to be final wearing surface. Screed mortar shall generally comprise sand and cement modified by additives or substituted by other materials such as polymers in order to provide specific performance requirements. For screeds of thickness greater than 40 mm, it is permissible to incorporate a proportion of 10 mm aggregate. Aggregates used for screed shall not contain deleterious materials such as coal or iron particles, which may affect finish surface of screed. Admixtures for mortar screed shall assist workability or alter rates of setting and hardening shall comply with appropriate part of BSEN 480 and BSEN 934. Polymer based additives may be used to improve adhesion and strength of thin or featured screeds. These shall be based on polyvinyl acetate PVA, polyvinyl acetate, styrene bitumen rubber SPR or acrylic polymers. Ready to use sand cement screeds shall comply with materials requirement of BSEN 998. Screed with a rapid drying time to enable earlier floor finish to be applied shall be used strictly in accordance with the manufacturer's instructions. Interface of screed in concrete substrata shall be specified as one of following options by engineer. Monolithic with concrete base, screed shall be applied with 3 hours of placing concrete base. Bonded to concrete base, screed shall be laid onto concrete base which is hardened and is subsequently been prepared to receive screed. Minimum thickness of screed shall be 25 mm and maximum thickness 40 mm. As an unbonded screed shall be laid on a separating layer. As a floating screed shall be laid on an insulating material. So unbonded screed and floating screed. Screed unbonded one to be on separating layer and floating screed to be on insulating material. Cement and sand screed mix shall have minimum amount of water added to give sufficient workability and allow material to be thoroughly compacted. Pan type mixes shall be used to ensure efficient mixing of materials. Cement to aggregate ratio shall be between 1 to 3 and 1 to 4.5 by weight. Mixing of sand, cement, water and admixtures shall ensure thorough homogeneous mixture with no balling up of cement. Screed shall be laid either between carefully labeled and two buttons of between steps of Screed laid and compacted to a finished level. For bonded screed, where a high degree of bond is required, surface latents of concrete base shall be mechanically removed to expose coarse aggregate. A thin layer of neat cement grout shall be applied to pre-wetted or dampened concrete and screed applied and compacted while grout is wet. Screed shall be fully compacted by heavy hand or mechanical tamping. Screed at joints around perimeter shall be particularly well compacted to avoid breaking out and curling. Screeds thicker than 50 mm shall be laid into approximately equal layers. Screed shall be kept protected by waterproof sheeting for at least 7 days after laying. Sheet and non-ceramic tiling finishes shall only be applied after screed has cured and necessary strength achieved. If requested by engineer, contract shall carry out soundness and impact test in accordance with BS 8203. Screed shall be laid in bays of a size to minimize thermal moisture contraction. Contraction or movement joints shall be provided as appropriate where shown on drawings or as they are directed by engineer. Base shall be laid alternatively. Base size shall be approximately 15 meters square for 100 mm thick screed and 12 meters square for 75 mm thick screed. Cellular concrete. Cellular concrete CC is conventional concrete where natural aggregate gravel is exchanged for an insulation medium, namely air, embedded in organic and biodegradable form. It behaves like conventional concrete, in particular concerning curing, hardening, and most important, aging. Cellular concrete infinitely increases its strength by hydration as long as you know exposed to humidity in atmosphere. CC offers more thermal insulation and substantially higher fire rating than conventional concrete. Minimum compressive strength shall be 4 MPa. Required density and strength of CC cellular concrete shall be specified on drawings and approved by engineer. Method of producing cellular concrete shall be shown on drawings or directed by engineer. Contractor shall submit full technical details of materials and method of production for CC along with a list of previous projects where particular system has been used. After source approval of material and system, contractor shall submit a mix design for CLC for approval by engineer. After review and approval of theoretical mix design, contractor shall carry out a trial mix to check workability of fresh concrete and to allow samples to be made for compressive strength and density. Engineer may also instruct that tests are carried out for abrasion, resistance, and thermal insulation properties. Cellular concrete shall not be used for structural reinforced members. Repairs of concrete. General extent and nature of defects in concrete shall be established in accordance with Part 15 of this section. Based on these results of engineer shall confirm acceptability of work and whether remedial works are required. If remedial works are required, contractor shall submit a detailed method statement identifying specific material to be used and sequence of activities for repair. Only proprietary proven material that forms part of standard repair system be used. Honeycombing or spalling. कल 1:30 इसका वो आ रहा है कोविड वाला टेस्ट कर रहे हैं. बंटी ने वो बुक किया है. अभी सो रही है. सो रही है अभी. अंदर में गई है. अच्छा चलो खैर. हनीकॉम्बिंग ऑफ स्पॉलिंग. गर्म पानी पीऊँगा, ठंडा नहीं पीता. मेरे खांस ठंड से गला चल जाता है. रहने दो, कोई नहीं. Honeycombing or spalling, where there is honeycombs concrete or concrete damaged by physical forces such as impact that has caused spalling, concrete shall be replaced using a high strength free flowing cementitious micro concrete. Area of repair shall be marked out and agreed with engineer. All honeycombs, loose, cracked or friable concrete in these areas be removed until sound concrete is reached. Due account shall be taken of propping or other instructions given by engineer regarding sequences of removal and repair. Equipment and methods used to break out concrete shall be such that no reinforcing steel or other embedded items such as conduits, lifting sockets or other inserts are loosened or damaged unless so directed by engineer. Where removal of concrete by mechanical means is difficult due to reinforcement congestion, then use of high pressure water jetting shall be considered and necessary provisions of our protecting rest of structures be made. Prepared void shall be profiled so that entrapment of air is avoided during repair process using fluid micro concrete. Minimum depth of repair shall be 40 mm throughout. Perimeter of area to be repaired shall first be cut to depth of 10 mm using a suitable tool. Feather edges shall not be accepted. Prepared concrete surface shall be sound and clean and free of loose particles, dust and debris. Where exposed reinforcement is sound, it shall be mechanically cleaned of dust and loose mill scale. Reinforcement damaged during removal of concrete or preparation process shall, if required by engineer, be repaired or replaced. Adequate formwork shall be provided in accordance with part 9 of this section. This shall be securely fixed to withstand hydraulic pressure of fluid microconcrete. Repair material without distortion or movement during placement. Formwork shall be watertight at all joints between panels and between formworks and existing concrete surface so as to prevent grout leakage. Formwork shall be constructed from appropriate materials as agreed with engineer to achieve required finish. Formwork surface that are to be in contact with repair microconcrete shall be treated with a suitable mold release agent. This shall be used in accordance with manufacturer's recommendations. Entry point of feed pipe into form shall be at lowest point of void. Sufficient hydrostatic head or pumping pressure shall be maintained to ensure that void is filled completely and no air remains entrapped. While necessary, provision shall be made for controllable village of points to prevent air entrapment and enable extent of flow of repair material to be assessed. Formwork shall be inspected by engineer and, if approved, filled with clean water, which demonstrates that formwork is grout tight and saturates prepared concrete surface. Formwork shall be then completely drained and resealed. In situations where completed repair be subject to constant immersion, an epoxy bonding agent shall be applied in accordance with manufacturer's instructions. Both compressive strength and flexural strength shall be at a water powder ratio of 0.18 and tested at 20 degrees Celsius. Thermal conductivity and elastic modulus of repair material shall be compatible with host concrete. If requested by engineer, recent test results of materials for following properties be submitted: thermal conductivity, elastic modulus BS1881, expansion characteristics ASTM C847 CRD 6218, 2A, flow characteristics UK DOT BD 27/86 paragraph 4.6b. Microconcrete shall be mixed with placed in accordance with manufacturer's instruction but recommendations, particularly with regard to water content, mixing equipment and placing time. As far as possible, placing of microconcrete shall be continuous. Mixing operations shall be timed so that there is minimal interruption in material flow. If, however, placing is interrupted, operation shall recommence as soon as possible while repair material retains its flow characteristics. Formwork shall not be removed until repair microconcrete has achieved a compressive strength of at least 10 MPa or as directed by engineer. Immediately after removal of formwork, repair area shall be cured in accordance with part 10 of this section. Repair material shall be shrinkage compensated in both liquid and cured state. Contain no metallic expansion system. Be pre-packed and factory quality controlled. Be a free-flowing cementitious material that has a coefficient of thermal expansion fully compatible with host concrete and which complies with requirements of table 16.3. 16.3 property requirements of microconcrete. Compressive strength is BSC 812390-3 at 28 day 50 MPa. Flexural strength BS451 at 28 day 10 MPa. Anchorage bond BS8110 passes. Crack injection. This clause of specification covers non-active cracks within concrete elements caused by shrinkage or other structural movement. Non-active cracks shall be injected with a low viscosity epoxy resin to fill and seal crack and restore structural integrity. Before to starting injection operation, it shall be established by testing and investigation work that cracks manifest within concrete elements due to either or both shrinkage or structural movement are non-active. Extent of cracks to be filled shall be as directed by engineer. Cracks to be filled shall be marked out in detail on concrete elements by contractor and agreed with engineer before processing. Extent of work may be adjusted by engineer as project proceeds according to conditions found. Grease, oil or other contaminants shall be removed. Algae and other biological growth shall also be removed by scrubbing with bactericide or detergent and clean water. If necessary, wire brushes shall be used. Loose or spalling areas of concrete, latent traces of paint or other coating material within marked out scope of work shall be removed. All cracks shall be thoroughly cleaned out using clean, oil-free compressed air. Both concrete surface and cracks shall be allowed to dry thoroughly before continuing. Injection nipples shall be fixed at intervals along length of each crack. Distance between each nipple will depend on width and depth of crack. Spacing shall be close enough to ensure that resin penetrate along cracks to next point of injection. This normally be between 200 mm and 100 mm. Each nipple shall be firmly bonded to concrete surface by using a sealant. Sealant be supplied in two pans, liquid base and hardener based. hardener system, liquid based and hardener system. Two components shall be thoroughly mixed together for 3 to 4 minutes until a putty-like consistency is achieved. Mixed sealant shall be applied to metal base of each surface. Fixed nipple. Mixed sealant shall be applied to metal base of each surface fixed nipple. They shall be pressed firmly into place and held for several seconds until secure. Mixed sealant shall be applied around each embedded nipple, ensuring a complete seal is made. In this way, all nipples shall be fixed along length of crack. In case of a wall or slab which is cracked, all way through, nipple shall be located on both sides with those at back placed at midway points between those it front. Surface of cracks between nipples shall be sealed with band of sealant 30 to 40 mm wide and 2 to 3 mm thick. Both sides if cracks which go all way through wall or slab shall be sealed in this way. Prepared cracks shall be allowed to cure for 12 to 24 hours or at low ambient temperatures 5 degrees to 12 degrees Celsius. Curing time will be extended and contractors shall ensure that surface sealants has adequately cured before continuing. One end of injection hose shall be attached to lowest nipple on vertical cracks or to either end of horizontal cracks. Each crack shall be treated in a single continuous operation. Sufficient material shall therefore be made ready before commencement of work. Contractors shall to ensure sufficient cracks are prepared to provide effective use of mixed material. Preparation, mixing and application of material shall be undertaken in a strict accordance with manufacturer's recommendations. Contractors to ensure that all necessary tools and equipments are on site. Both compressive strength and flexural strength shall be tested at 7 days. Material shall exhibit excellent bond to concrete and when tested for tensile adhesion, failure shall be in concrete and not at interface. Injection resin shall be of pre-packaged or pre-weighed type and only use of full units be allowed. No part pack or on-site batching be allowed under whatever circumstances. In all operations of storage, mixing and application, contractor shall comply with health and safety recommendations of manufacturers and governing authorities. Injecting system shall be allowed to cure for 24 hours and be left undisturbed for this time. Nipples and bands of surface sealed shall then be removed and damaged areas made good to satisfaction of engineer. Injection material shall be compatible with host concrete and shall have properties shown in table 16.4 when tested in accordance with relevant standards. Property requirements of epoxy crack injection material, property method and minimum value, compressive strength BS4551, BS278 to BS631 70 MPa, flexural strength BSEN123905, polyester resin concrete piping systems for non-pressure drainage and sewerage. Polyester resin concrete is a mixture formed from aggregates and fillers which are bound together using polyester resin, also called polymer concrete pipes, as defined in ISO 18672-1 or ASTM D6783 with amendments given below. Polyester resin concrete is permitted for use in infrastructure, drainage and sewerage systems, pipes, manholes, soakways. Resin used in pipe system manufactured per ISO 18672-1 shall have a Temperature of deflection of at least 85 degrees Celsius when tested in accordance with method A of ISO 75-2 with test specimen in edgewise position. It shall also conform to applicable requirements of EN 13121-1. Miscellaneous. Resin used in pipe system manufactured per ASTM 6783 shall have a minimum deflection temperature of 85 degrees Celsius. When tested at 1.82 MPa following test methods, DS648 resin content shall not be less than 7% of weight of sample as determined by test method DIG 584. Minimum strength. Minimum strength classes for different pipe shapes are given below. Minimum strength classes for pipes designated PRC, OC or PRC TC. Nominal diameter size DN 150 less than DN less than equal to 500, PRC OC 180 Newton per meter mm, PRC TC 180 Newton per mm, 600 less than DN less than 1000, 145, 160, 1200 less than DN less than 3000, 120, 145. Now minimum strength class of pipes designated PRC OE or PRC TE. Nominal width of height, width of height WNHN. Strength class now 300 oblique 450. 300 is now width and 450 is height. So 300 450 less than equal to WN or H. 600 900 180 180 700 1050 less than equal to W and oblique HN less than equal to 10 1000 over 1500 145 160 1200 over 1800 less than equal to W and HN less than equal to 1400 over 2100 120 145. Minimum strength class for pipes designated PRC OK or PRC TK. It's also similar. Nominal diameter 800 less than equal to DN less than equal to 1000 PRC OK 145 PRC TK 160 1200 less than equal to DN less than equal to 1800 120 and 140. And this part now structural precast concrete. Structural precast concrete. Scope, references, submittals, qualifications, quality assurance, quality control, testing, delivery, storage and handling, design, loading, actions and structural members selection, materials, general, reinforcing bars, bearing pads, embedded steels, forming, general, tolerances, installation, general, survey, guying, bracing and shoring, adjustments and correction, erection, tolerances, welding, grouting, field cutting. Structural precast concrete general work included in this section comprises furnishing all plant labor, equipment, appliances and materials and performing all operations in connection with structural precast concrete work. Sections are related: Part 2 aggregate, Part 3 cementitious material, Part 5 admixtures, Part 6 property requirement, Part 7 concrete plants, Part 8 transportation and placing of concrete, Part 9 formwork, Part 10 curing, Part 11 reinforcement, Part 15 hot weather concreting. References are to standard specification for highway bridges, Section 25, ACI 5232R guide for precast cellular concrete floor, roof and wall unit, ACI 533R guide for precast concrete wall panels, ACI 5331R design responsibility for architectural precast concrete projects, ACI 543 design, manufacture installation of concrete piles, ACI 5501R09 guide to emulating cast in place detailing for seismic design of precast concrete structures, ASCE SCI 705 minimum design loads of buildings and other structures, ACI 31811 building code requirements for structural concrete, BS 8110 structural use of concrete, BSEN 1991-114 Euro Code 1 action of structures, general actions, surveyed actions, BSN 199-1-10 Code 2 design of concrete structures, general use rules and rules for buildings, ISO 9000 quality management system fundamentals vocabulary, Precious Concrete Institute PCI Manual 116. Submittals. Manufacturer's literature. Contractor shall provide copies of manufacturer specifications and installation instructions for each item of proprietary material to be used showing compliance With this specification, information on equipment, embedded items, and other accessories shall be provided. Design mixes copies of mixed design with support materials. Requirements of mixed design shall be in accordance with Part 6 and 7 of this section. Product design criteria, loadings for design, initial handling and erection stresses, all dead and live loads as specified on contract drawings or as required, all other loads specified for member where they are applicable, product design calculations. Design calculation be performed by structural engineer experienced in precast concrete design, shall cover all stages of handling, transportation and erection. Design shall be carried out in accordance with requirements of BSEN 1992-1- or relevant essay and be accepted by engineer. Calculations for designer precast members shall be supported by a statement explaining principle of design and type of analysis adopted. Influence of individual members in achieving overall stability of structural should be considered. Computer programs used in design shall be fully described and details of input and printout shall be presented in a manner which can be readily understood and following requirements to be met. Program manuals and instructions of programs used shall be made available to engineer upon request. Where such program cannot be demonstrated by contractor to have been fully checked or where engineer considers necessary, contractor shall run such test examples as engineer may choose in order to verify completeness and accuracy of program. Members that are exposed to weather shall be designed to provide for movement of components without damage. Failure of joint seals, undue stress on fasteners, or other detrimental effects when subject to seasonal or cyclic day per night temperature change. Precast systems shall be designed to accommodate construction tolerances, deflection of other building structural members, and clearance of intended openings. Calculate structural properties of framing members in accordance with BS 8110 or BS EN 1992-1- or relevant essay codes. Shop drawings, contractor shall provide following information for approval of engineer layout plans and detailed fabrication and placement drawings for each structural precast element. Shop drawings are to include following information: size, grade, profile and dimensions of all materials used, connection and anchorage details, lifting devices, locations and handling limitations, steel reinforcement details, all openings, sleeves, inserts and other provisions in full coordination with all trades in contact. Identification marks, erection procedures, detailed outline of sequence and methods of erection, including but not limited to types, capacities and number of cranage, methods of support and transportation. Fabrication records. A record shall be kept for every piece of precast element produced showing following types and number, type and number, date of pour, concrete test results, shop drawing reference number, type and duration of curing, date of delivery to site, date of fixing in position. Test reports, copies of all testing and inspection reports, trial panels. Contractor shall produce trial panels in accordance with requirements of Part 10 of this specific section. Trial panels shall be retained for reference purpose for acceptance of production work. Qualifications. Structural precast work shall be executed by an approved specialist subcontractor for casting and also for transportation, handling and erection. Contractor may execute this work himself if he can satisfy engineer that it has sufficient experience and expertise in this field. As a minimum, contractor shall provide satisfactory evidence that its tradesmen and their supervisory personnel engaged in such work have successful experience with work comparable to that shown and specified. provide details of organized quality control and testing procedures. Quality requirement: precast concrete supplier shall have a quality assurance scheme that meets ISO 9000 or equivalent. All work shall be performed secure for project homogeneous concrete having required strength, surface finish, materials, durability, and weathering resistance, without planes of weakness or other structural defects, and free of honeycombs, air pockets, voids, projections, offsets of plane, and other defacements of concrete. No alterations or substitutions of structural systems shown on drawings are permitted unless otherwise specified. Contractor shall supervise and coordinate all phases of structural precast concrete construction process and be responsible for complete manufacturing process. All methods of manufacture and practices of handling raw materials and manufactured concrete shall be reviewed by engineer before execution of structural precast concrete work at least 14 days before beginning of precasting work. Only materials of known quality shall be incorporated in work. All materials shall be properly selected, reviewed, and approved by engineer before use and maintained during shipment, storage, and use. Construction system and technique shall be properly selected, reviewed, and approved by engineer before use and maintained throughout complete structural precast concrete construction phase. Adequate spare equipment, parts, additional components, and repair facilities shall be available for all tools and equipments. Regardless of approvals by engineer, contractor shall be responsible for all materials and methods of structural precast concrete work. If work doesn't meet specified requirements, contractor shall, at no additional cost to employer, implement removal, replacement, or remedial work, revise procedures or materials to prevent recurrence of unacceptable work. Quality control. Contractor shall prepare and provide quality control program for structural precast concrete work with particular attention to details, pre-checking, processes, procedures, and close supervision, and in particular, contractor shall, in order to assure that proper work is performed to prevent later corrective actions, assign at least one experienced supervisor full-time to provide quality control for structural precast concrete work. Assignment shall not relieve contractor other quality control personnel. वही हुआ मुझे क्या पता हाँ तो नहीं है. Assignment will not relieve contractor other quality control personnel of their duties relative to quality control of structural requirements and surface finish of structural precast concrete work. Contractor shall arrange for training of quality control personnel who perform quality control of structural precast concrete work and whose training shall include but not be limited to material evaluation, special mix design techniques, mix placements, special mix design techniques, and mix placement. Vibrator selection and use, formwork detail, formwork protection, release agent use, reinforcing steel, detailing and installation, finishing equipment and technique, corrective procedure and protection of completed work. Contractor's quality control personnel shall be responsible for verifying all details necessary to produce final structural design objectives. Contractor's quality control personnel shall also verify quality of structural precast concrete work and guide production of results which be within acceptable tolerances. Testing: concrete shall be tested as specified in part 6 of this section. Contractor shall furnish labor required to facilitate testing, inform engineer with at least 1 day's advance notice when concrete is to be placed, provide storage facility for concrete, test cubes, provide material samples and access to materials as required for testing. Should batching plant be located more than 500 meters away from site offices, contract shall provide suitable transport acceptable to engineer for sole use of engineer's staff. Contract shall station a qualified technician at casting site to continuously test, inspect and report on following: that concrete testing is being carried out in accordance with the requirement of part 6 of this section. Check following and verify conformance with the specified requirements and approved shop drawings. All reinforcement bars, all reinforcing bars, all embedded items, all formwork. ये कौन आया था आदमी?
सब्जी वाला।
ये सब्जी वाला था?
ऑटो में जो ले गया था तुझे?
पहचानने नहीं आया मेरे को। अच्छा अच्छा अच्छा। वो कल 1:30 बजे आएंगे तेरा कोविड का
कौन
टेस्ट करने।
कौन?
कोविड वाले
अच्छा
1:30 बजे आएंगे कल। Check all openings and provisions for coordination with all trades and contract as shown on approved shop drawing. Contract shall provide facilities and equipment for conducting all tests specified herein except for strength test, which should be carried out by an approved independent testing agency. Delivery, storage and handling. Structural precast elements shall be removed from form without damaging or over-stressing and stored or placed for transportation on a stable bed that shall not be allowed distortion of member. Separate stacked members with suitable battens and bracing. Mark each member with an identifying reference or piece mark and date of casting. All piece marks are to be correlated with test reports and plan layouts or erection drawings. Structural precast elements shall be transported with sufficient battens, bracing and support so as to prevent overstress by vibration or impact loadings. Contractor shall submit proposed method of transportation to engineer for approval. The structural precast unit shall be stored, handled and transported in a manner that avoid undue strains, hair cracks, staining or other damage. Contractor shall deliver units from casting sites to project site in accordance with schedule and proper setting disciplines. Proper setting sequence. Structural precast units shall be stored free of ground and protected from wind or rain splashes. Units shall be covered and protected from dust, dirt, or other straining materials. During fabrication, construction, and after erection, contractor shall protect castings to avoid possibility of damage. Design loading actions and structural member selection. Provisions of this clause shall apply if contractor is responsible for design of structural precast units. Precast elements shall be designed to withstand all loading conditions against which strength and serviceability must be measured. Vertical load shall include self-weight of precast element, floor coverings and live load as indicated on contract drawings. Wind loads shall be calculated based on wind speed provided in section 1 part 1 clause 152. Account shall be taken of loads and deformation caused by temperature and time dependent deformations. For such purpose 55 degrees Celsius temperature variation and 90% relative humidity should be considered for all members except exterior elements, and facade elements shall consider 85 degrees Celsius. Precast elements shall be designed in accordance with BSEN 1992-1-1 or relevant ACI code. Design tensile stresses should not exceed design flexure tensile stresses of concrete at particular age of concrete. Nominal core to steel including links must meet durability requirement of severe conditions. Nominal cover to steel including links must meet durability requirement of severe condition of exposure and to meet requirement of 2 hours period of fire resistance as provided for in BSCN 1992-1-1 or relevant ACI code. Total deflection of precast element should be limited to 1/350 of span of this element. Plan and design for openings of buildings services where required for necessary materials in general. Contractor shall obtain cement aggregate and water from a single source sufficient to complete entire structural precast concrete work to assure regularity of appearance and uniformity and color. Contractor shall provide all material in accordance with and meet applicable requirements of this section. Reinforcing bars shall conform to requirement of part 11 of this section. Bearing pads, there shall be elastomeric neoprene conforming to ASHTO standard specification. For highway bridges, section 25 with following stipulation. Use unfactored load for design. Maximum compressive stress 0.7 MPa. Maximum shear stress 0.07 MPa. maximum shear deformation 1 over 2 thickness, maximum compressive strain 15%. Embedded steel shall be stainless steel grade 316L, forming general. Forms and casting beds are to be firmly sealed so as not to deflect or be placed. Forms and castings beds are to be firmly sealed so as not to deflect or be displaced under concreting or tensioning bed loads. Correct for thermally induced strains or forces. For member penetrations larger than 150 mm, coring or field cutting is not permitted unless approved by engineer. Clean and coat forms with release agents before installation of reinforcing or embedments. Clean and coat forms with release agents before installation or reinforcing or embedments. Tolerance. Permissible deviations of form surfaces are not to exceed tolerances outlined in PCI Manual 116 with items as summarized or modified in Table 17.1 tolerances of structural precast concrete. Description dimensions plus minus 5 mm, width plus minus 3 mm, thickness stem plus minus 3 mm, flange plus minus 2 mm, embedment or penetration location plus minus 0.2%, straightness plus minus 3 mm for 300 cm and squareness plus minus 3 mm. Installation. Contractor's erection responsibility includes safe and proper placing, aligning, and leveling of structural precast elements on accepted bearing surfaces and affecting their proper fastening. Survey. Before placement of structural precast elements, contractor shall survey and maintain all temporary supports shown are required to control alignment and deflection. Temporary support shall be retained until framing element braced, thereby have attained integral stability in accordance with design. Guying, bracing, and shoring. Contractor shall install in proper sequence and maintain all temporary supports shown are required to control alignment, deflection, and stress levels. Temporary support shall be retained until framing elements braced, thereby have attained integral stability in accordance with design. Adjustment and correction. Contractor shall compensate and correct for misaligning effect of temperature, draw from welding, bolting, or erection sequence or grouting. Erection tolerances. ये ले लेना. Erection tolerances. erection tolerances. So I have taken tea, let me now finish it. Following erection tolerances shall apply unless otherwise specified in contract. Variation from plumb 6 mm in 6 mm run. 6 mm in 6 meter run, so 1 in 1 mm in 1 meter. 12 mm total in 12 meter or longer run. Variation from level or elevation 6 mm in runs, 12 mm in 12 meter runs, maximum 12 mm at single location. Variation from position in plan plus minus 12 mm maximum. Offset in alignment of adjacent members at joints 1.5 mm in 3 meter and 6 mm maximum. Welding. Where permission for welding is given by engineer, following shall apply. Welding will not affect until all adjacent elements to be connected have been aligned, firmly seated and braced. Control of heat built up by limiting voltage, electrode size and rate. Spoiled or heat damaged concrete around weldments shall be acceptable. Grouting. Joints, gaps and connections shall be filled with grout as shown on drawings and as approved by engineer. Field cutting. Field cutting of holes may be done only with engineer's concurrence and only with power saws or core drills. Steel reinforcement or pre-stressing strand shall be avoided. Where reinforcement or strand is damaged, unit shall be repaired to satisfaction of engineer or rejected. Maximum hole size shall be 150 mm diameter or as limited by member size or strand location. Whatever cracks, spalls and sharp corners created by field cutting are to be ground, erased, eased and patched with epoxy type bonding and patching compounds. Pre-stressed concrete contains pre-stressed concrete. It was precast, now it's pre-stressed concrete. Scope, reference, submittals, storage and handling, pre-stressing, general wires and stands, sheaths, cores and ducts, anchorage, jacking equipment, tensioning, grouting, grout, mixer, grout, trials. Pre-stressed concrete. This section describes requirements of pre-stressed post-tension concrete, including materials and procedures for installation, stressing and grouting. Related sections and parts are as follows. Part 2 aggregates, Part 3 cementitious materials, Part 4 water, Part 5 mixers, Part 6 property requirement, Part 7 concrete plants, Part 6 transportation placing of concrete, Part 9 formwork, Part 10 curing, Part 11 reinforcement, Part 15 hot weather condition, concreting, Part 16 miscellaneous. And let us see, time is now. This is of course 3:13:43. No problem, we can continue for just a minute. Okay, ACI 325 seminar recommendation of designing pre-stressed concrete pavements. ACI 343 are analysis and design of reinforced concrete bridge structures. ACI 353 are seismic design of liquid containing concrete structures. ACI 3581 are analysis and design of reinforced and pre-stressed concrete guideway structures. ACI 372 design and construction of circular wire and strand wrapped pre-stressed concrete structures. ACI 373 are design and construction of circular pre-stressed concrete structures with circumferential tendons. ACI 4233 are recommendations for concrete members pre-stressed with unbonded tendons. ASTM A811, A881, A881